forward. Uh, could you please could we have the audience move forward so that we'll have more of the audience in front? Kindly occupy the front seats. We're about to start. Assalamualaikum warahmatullahi wabarakatuh. Ladies and gentlemen, welcome to the third session of the GiKS conference, The Green Sustainable Future in the Kingdom of Saudi Arabia. I am Romal Maneha, Research Scientist 2 in KFUPM. It is my honor to host the session focused on ecosystem-based management of marine resources. Ecosystem-based management, also known as the ecosystem approach, is a move away from single species or sector approach in managing environmental problems, which is widely considered as insufficient and often led to the failure to protect the marine ecosystems, as well as terrestrial ecosystems. Ecosystem-based management has been defined in different ways based on the function of the approach by global organizations, ranging from narrow to broad definition. For example, a broader definition by the Communications Partnership for Science and the Sea, COMPAS, which is composed of over 200 scientists and policymakers. Ecosystem-based management is an integrated approach to management that considers the entire ecosystem, including humans. The goal of ecosystem-based management is to maintain an ecosystem in a healthy, productive, and resilient condition so that it can provide the services that humans want and need. Ecosystem-based management differs from current approaches that usually focus on a single species, sector, or activity. It considers the cumulative impacts of different sectors. We are grateful to our esteemed speakers coming from different parts of the world to provide us examples of how ecosystem-based management is implemented with practical lessons for adaptation into the Saudi waters. All the way from the high-latitude country of Norway to the Western Pacific side represented by the Philippines, and exemplary representations from the Arabian Peninsula, particularly from Kuwait and Saudi Arabia. Our first keynote speaker is Dr. Faiza Al-Yamani, the Executive Director of the Environment and Life Sciences Research Center of the Kuwait Institute for Scientific Research. Dr. Al-Yamani obtained her PhD in Biological Oceanography from the Rosenshell School of Marine and Atmospheric Science in the University of Miami. Her fields of research covers a broad spectrum, starting from trophic relationships in marine plankton communities and food chain dynamics, plankton ecology, physical regulation of biological systems, fisheries oceanography, ecosystem restoration science, coastal zone management, development of human resources in interdisciplinary oceanography, oceanography data management, and marine protected areas. Dr. Al-Yamani is also the principal investigator of the Kuwait Institute for Scientific Research Oceanography Group that works on the hydrographic, hydrodynamics, and biological aspects of Kuwait's marine ecosystem since 1992. Ladies and gentlemen, Let us all welcome Dr. Faiza Al-Yamani.
Bismillah ar-Rahman ar-Rahim. Good morning, everybody. I would like to start first by thanking KFUPM for their hospitality and for inviting me to attend this important meeting. So the goal of this presentation is to provide an overview of the key principles and practice of ecosystem-based management, and to raise awareness about the importance of implementing ecosystem-based management in the Arabian Gulf. Thank you, that's good. Okay. That's good. The outline, you see there are several subject matters that will be discussed in this presentation, including the principles of EBM, ecosystem-based management, the strategies of EBM, the implementation of EBM, the challenges in implementing EBM, successful examples, and innovative approaches. Today, unfortunately, we are witnessing a depressing decline in our productive marine ecosystems due to the unmanaged uses of humans and different activities that are not managed in a sustainable way. Then the seas are exposed to very different stressors, natural and human-induced. Addressing these threats demands a holistic approach where we consider the interconnectedness of the ecosystems and human activities. It requires community engagement to achieve sustainable solutions and requires regional and global cooperation as ocean health transcends borders and demands unified actions. This diagram encompasses the different components needed to implement ecosystem-based management. It displays the interconnectedness of all living organisms. It displays the interconnectedness of all living organisms and their physical environment and the impacts of the different anthropogenic factors. This table summarizes the difference between the conventional management approach and the ecosystem-based management. In terms of the focus, conventional management focuses primarily on individual fish or sectors or species, neglecting the broader ecosystem context and overlooking their interactions with other species and the environment. The EBM focuses on the entire marine ecosystem and its complex interaction and recognizes the interconnectedness of the ecosystem and aims to manage them holistically. In terms of management strategies, the conventional approach relies mainly on species-specific measures like catch limits, gear restriction, minimum size limits in terms of fisheries management, while the EBM employs a variety of holistic strategies. These are EBM strategies like establishing marine protected areas, habitat restoration, pollution control, adaptive fishing regulations that consider predator-prey relationships. For decision-making, usually for the conventional approach, decisions are often made by fisheries managers and policymakers based on science, while the ABM involves all the stakeholders in the planning and in the implementation of the EBM. These stakeholders include scientists, fishermen, conservationists, policymakers, and the affected community. So you end up at the end with a balanced decision making. And of course, the monitoring for the from conventional, it's limited to specific fish population, target species, while the EBM emphasizes continuous monitoring of ecological indicators, and of course it practices adaptive management, because when you get more data, long-term data, then you get more understanding of the ecosystem and you can modify your management plan. The ecosystem-based management also recognizes and considers the threats to the marine environment and the ecosystems. And examples of these threats are overfishing, which depletes fish populations, pollution, which harm marine life and degrade habitats, habitat destruction, impacting the biodiversity and productivity, and climate change, rising seawater temperature, acidification, and changes in sea level. All these, alter species distribution and disrupting important ecological processes. So there are different strategies to mitigate all these threats. We have to remember that the specific strategies employed in EBM will vary depending on the unique characteristics of each marine ecosystem that we want to conserve or restore or rehabilitate, and the specific challenges faced in that ecosystem and the prevailing social and economic context. Examples of the EBM strategies. The first is establishing marine protected areas. This helps to recover a disturbed environment or the loss in species diversity. Another one is marine spatial planning, which involves zoning different areas of the sea for the different users, and that minimizes the conflicts between different user groups. For ecosystem-based fisheries management, that strategy implements sustainable fishing practices, setting catch limits, considering bycatch, and utilizing gear restrictions to minimize habitat damage. Pollution control measures. The strategy also addresses the sources of pollution and helps to protect water quality and safeguard the health of the marine ecosystem. Also, another strategy is habitat restoration, which restores degraded ecosystem and habitats like coral reefs, mangroves, seagrass beds through active planting and habitat creation structures. The monitoring, as mentioned before, EBM, there's continuous monitoring that's required, so you gain the knowledge and also accommodate the variability, and then that will help you to, when you have the flexible management, to modify that management plan to accommodate the new information. Another important aspect is the stakeholder engagement. You need the participation of the different stakeholders, including scientists, fishermen, biologists, conservation, policymakers, local community in decision-making process. And of course, research and innovation. So continuously, the EBM requires investing in research to improve the understanding. Now we come to the practical part, which is implementing the ecosystem-based management. The first thing you need to plan, the first step is to define the area of concern. You must have an area where you think there is a problem that needs to be looked at. So you define the area, you identify the specific ecosystem or region where EBM will be implemented, and you have to consider the ecological characteristics, resource uses, and existing management frameworks. You have to do like a literature search. You gather all the existing information, all the data that's available, published or in gray literature, and whether it's on species, abundance, habitat, conditions, environmental factors, human activities that are impacting the ecosystem. And then you have to identify the gaps in knowledge. Next, you have to identify the threats to the ecosystem, like pollution. Is it pollution that's really you're concerned with, or overfishing, or habitat degradation? And what are the potential opportunities for improvement? Like, would it be restoration that will help the ecosystem, sustainable use practices, you know, any of the solutions that you think would help the ecosystem? And most importantly, to identify the ecological goals. Like, what do you want to get out of this plan? What is the outcome that you need to get? Such, for example, like maintaining healthy fish population or protecting biodiversity, ensuring water quality. Very important point is the stakeholder engagement. In the planning, from the beginning, in the planning step. So you engage all these important stakeholders, and this will allow them to build trust between each other and with the scientists. And after all this is done, you develop the EBM plan. So you formulate the plan, and it should outline specific management strategies, the actions, timelines for achieving the desired ecological goal. This plan should be flexible. As mentioned before, you're continuously collecting data, and with collecting data, long-term, you're learning more, and that will give you information that will help you accommodate the changes and the evolving circumstances. Now, you have to put the strategies into action. So if you have decided that to help or to mitigate the threat is establishment of a marine protected area, then a marine protected area should be identified and established. Then once you establish the marine protected area, then you start the practical part, which is monitoring and trying to get information on the different biological indicators, and also the physical settings, all the information that you need to be able to understand how the system works. Also, it's important, like while you're collecting, you evaluating your management plan and to see if it's effective and to identify areas of improvement. The information you obtain, you have to communicate with your stakeholders, policymakers, and also to highlight the benefits and challenges of EBM, because there are challenges in implementing EBM. And very important to invest in research and innovation. Additional aspects is, of course, you have to align your EBM strategies with existing laws and policies on fisheries, environment, spatial planning to ensure coherence and effectiveness. And this is, the second point is very important, is the funding, because it is costly, you know, to have long-term monitoring for the whole ecosystem that you're concerned with. And you need the commitment from the government and the stakeholders, and sometimes international organizations. So EBM is not a one-size-fits-all approach. We have seen the different strategies that you could use depending on the characteristics of each ecosystem. What are some of the examples that are used in ecosystem-based management? For monitoring, you could use the satellite imageries, aerial photography, underwater drones and cameras. It helps you to collect the data and information. And another important point is to engage the citizens, what's called citizen science. It's a very powerful approach, actually, Of course, it has to follow some scientific protocols. And nowadays, the social media is helping a great deal by disseminating the information to the scientists and to the public. This diagram displays the process of public involvement in scientific data collection, which should follow a standard protocol. So it's not like a haphazard thing. And scientists, once the data arrive from the people who are conveying the data, scientists should validate the data before analysis and interpretation. Some of the tools also used in EBM is the ecosystem modeling. There are several models that could be helpful while implementing the EBM, such as food web models that simulates the interactions between different species, and biogeochemical models that track the flow of nutrients and pollutants through the ecosystem, and spatial models which map the distribution of species and habitats. These are just examples. Also, there are decision support systems, web-based system that will help the managers to evaluate the different management options. Stakeholder engagement tools also are available, and cost-benefit analysis for the evaluation of the economic and social implications of the different management strategies. There are also visualization tools like animation interactive maps that helps the public and the policymakers to understand and the rationale. There is, of course, the educational part where you raise awareness. There are several of these, and knowledge sharing platform for the exchange of data and information. And of course, the legal and regulatory tools where you have to check and see what are the regulations for the area that you are working on. Now, artificial intelligence is becoming a very powerful tool, helping in the data collection and analysis. There are algorithms that are used. It gets you to analyze the data in real time. And there are data that comes from sensors, underwater cameras and drones, and autonomous underwater vehicles. Also, there are algorithms that will identify marine species in images and videos, allowing for faster and more accurate surveys of biodiversity. There are modeling and prediction tools, for ecosystem simulation using AI, which aids in that, and early warning systems like for coral bleaching or for harmful algal blooms. Decision making also, there are systems to help the managers to understand in a simpler way the whole process. But there are challenges in the implementation of ecosystem-based management. First is the data scarcity. For EBM, you need to collect extensive data and long-term. So that is costly and expensive. Also, you need to have sophisticated modeling to understand the impacts of the changes on the ecosystem. That's why political and commitment from the government is required, because this is a long-term commitment and has to be sustained funding. And that's what some countries are facing, and definitely Kuwait is facing that, because there's no enough funding for long-term. And another important challenge is the different stakeholders. They have different priorities. So it's difficult sometimes to reach an agreement on management strategies. And sometimes you need also to have capacity building programs to educate and to make the managers, stakeholders aware, so they can understand why you're doing this approach and what's the benefits. Some of the key stakeholders that are important for implementing EBM, of course, they're the government agencies like the environmental authorities and the fisheries authorities, research institutions that provide the monitoring data and evaluate the EBM strategy, and the environmental non-governmental organization, the industry and business, fishing industry, that should adapt to sustainable fishing practices, aquaculture industry, and the maritime industries, and the tourism and recreation industries that should promote responsible tourism activities. So EBM requires collaboration and input from a diverse range of stakeholders to ensure the comprehensive and effective management of marine resources. Most important also to have the funding. That is very important for a successful plan. The following slides, I'll present a few examples of the diverse applications of EBM across the globe. These examples are chosen for their diversity and unique features. Even though they might be different, using different strategies of EBM, they all share common elements, which are science-based decision-making, using scientific data, stakeholder participation, involving them in the planning and implementation of EBM, and adaptive management, as we mentioned before, continuously monitor and adapt the management approaches. So a few of the examples, I will go over them very quickly because I don't want to take a lot of time. I think I have 10, 20 minutes, okay. So the first example is the Great Barrier Reef Marine Park, which is in Australia. It's a global leader in EBM. It utilizes zoning system to balance conservation with human activities like tourism and fishing. And the park's success lies in its comprehensive approach, including habitat protection, fisheries management, water quality control, and conducting research and the long-term monitoring. Another example is the Hokkaido fishery in Japan, and that's the approach is to successfully combine the traditional practices with modern science-based management, and it's a community-based management where the fishermen are involved and they have a strong say in the managing the fishery. More of the examples, I will not go over them, but some that most of these are in the fisheries sector. This is an example of protecting coral reefs and fisheries, which is in the Kembe Bay Marine in New Guinea. And as you see, they involve traditional management, collaborative decisions on making, sustainable fishing practices. The other one is the Rockall Marine Protected Area. They're protecting a sensitive deep sea environment. And of course, that involves several features like transboundary management and habitat protection and scientific research. And another example for coral reef restoration, which is in Belize, and the Lagoon Project New Zealand. Also, there, of course, involves collaborative management, improved water quality, and cultural revitalization. And this example is about the marine sanctuary that it involves education, awareness, economic benefits, and no-take zone. So actually, you cannot go and remove or fish for biota. So these examples illustrate the diverse applications of EBM. Each one demonstrates that success often concentrates on collaboration, science-based decision-making, and integrating cultural and social considerations. Now we come to the Arabian Gulf. Even though the Gulf has a stressful environment, and however, it hosts a variety of marine ecosystems, each with its unique characteristics and ecological importance. You have the coral reefs, mangrove forests, seagrass meadows, mudflats and salt marshes, open waters, and hypersaline lagoons. These Gulf ecosystems are considered valued ecosystem components, and they provide important ecological goods and services. The Arabian Gulf suffers, like many of the other seas, from threats like declining fish stocks, the overfishing, from degradation of the ecosystems, from pollution, habitat destruction, and climate change, and limited knowledge, so our understanding of the Gulf's complex ecosystem, the dynamic, is still incomplete. And we have inadequate stakeholder participation. So I'll give some examples of the EBM, or marine protected areas, in the Gulf region. Again, you know, it's still in the initial stage. You know, the initiatives, promising initiatives are there, but there's more work to be done. However, the success is in at least establishing some of the MPAs in the region. For example, in the United Arab Emirates, there are 21 implemented MPA, marine protected areas. Example is the Marjan Island Marine Reserve. And this project protects the diverse habitats like mangroves, seagrass beds, and coral reefs. And the key successes include implementing the successful coral reef restoration programs and engaging the local communities in conservation. In Bahrain, there are 6 implemented marine protected areas, like, for example, the Hawar Islands Marine Protected Area, safeguarding critical habitats and vulnerable species. And it includes zoning the area. It's one of the strategies for protecting the environment is zoning the area to regulate different activities and conducting the monitoring, collaborating with regional research institutions for enhanced knowledge. Saudi Arabia, there are 9 implemented marine protected areas and 6 proposed marine protected areas. The main objectives of the Saudi Arabian protected areas, the management of the ecosystem, is to achieve Vision 2030 according to the Saudi Green Initiative, preserving natural habitats, actually it's protecting 30% of the land and sea areas, preserving natural habitats, biodiversity in the kingdom, and achieving the kingdom's commitment to the Convention on Biological Diversity, the CBD, and Sustainable Development Goals, especially Goal 14. An example is the Jubail Marine Protected Area. It's in the Arabian Gulf. It's a very successful MPA. Another one in the Red Sea is the Farsan Islands Protected Areas. It is now classified by UNESCO as part of the Man and Biosphere, and it's the first Saudi protected area registered in such a program. For Kuwait, we have 3 implemented protected areas and 19 proposed. One example is the Sulaybikhat Marine Protected Area. It's recently started. We finished the first phase, which is collecting, doing some monitoring, collecting the short-term data, and then based on the short-term data to formulate the long-term management plan. So this MPA offers protection to significant habitats like seagrass beds, mangroves, and intertidal mudflats. vital for the diverse marine. This area has very rich intertidal mudflats and very important species. Some are new to science. It's one of the very rich environments that one has to protect. There are many projects now that are happening around, and I hope the government doesn't allow the investors to reach this area because it's in the middle. So anyway, at least there is an effort, and the success includes developing and implementing models for sustainable fishing practices, monitoring and assessing the health of diverse marine habitats, including seagrass and the mangroves, and providing scientific recommendation data to inform ecosystem-based management policy decisions in Kuwait. The Sulaibihat Bay MPA is part of Kuwait's National Plan for Integrated Coastal Zone Management, emphasizing a holistic approach to marine resource management. We have some challenges, of course, the limited enforcement and implementing the regulations. It's very difficult, you know, I mean, it needs like 24 hours just surveillance and following, and so it's not easy. Even though the area is small, it's a small area, but still, it's not that easy, you know, for the enforcement. Maybe in the future there will be more, I think, measures. Addressing the pollutions around the area, there is a desalination plant, there is a sewage outlet. We're trying to notify the government that, you know, they have to have a solution for this to minimize the anthropogenic input. And stakeholder engagement also is not that it's not very strong, so it needs strengthening, and especially with the local community and fishermen. Fishermen still, they don't think this is important, and they go and fish close by or sometimes enter the MPA. That's where, you know, the limited enforcement is needed, and the public awareness and education for the fishermen. And in Qatar, there are 2 implemented MPAs and 1 proposed. In Oman, there are 8 implemented MPAs. What are some of the research studies needed for the ecosystem-based management for the Gulf? Implementing EPM effectively requires several research studies, and research priorities will vary depending on the specific ecosystem and the management goals. So, very important, of course, when you have lack of knowledge, is to gain understanding by doing more research and monitoring, long-term monitoring. And you have to include connectivity studies, where you include the predator-prey relationships, the early life stages, and larval dispersal patterns. Then you really need to have the understanding of the complex food web and the interactions. You need to develop the models to predict the ecosystem response to various environmental changes, human activities, and management interventions. That's a costly thing, and that's where the commitment is needed from the government. And then, of course, studies on the human impacts, sustainability, like fishing impacts of the different gears, practices on target and non-target species, including bycatch and discards, the pollution types, effects of different pollutants on marine ecosystem, including larval fish, sensitive habitats, and overall ecosystem health, and climate change impacts, the potential consequences of climate change for marine ecosystem, including rising seawater temperature, ocean acidification, and extreme weather events. And a very important one is the quantifying the economic and social values of healthy marine ecosystems. Some of the innovative approaches to protect the Arabian Gulf and implementing EPM is utilizing the technology available like satellites, ocean robots, drone-based monitoring, the surveillance systems that are available, which help in getting you the real-time data and analysis, the environmental DNA, which will help in identifying the organisms through their genetic material, the artificial intelligence-powered data analysis, especially the vast data sets that are generated from the monitoring systems, and of course, involving the citizen science engagement. There are several mobile apps and online platforms, but you need to also develop new ones according to the needs and engage the local communities in reporting the environmental issues. Okay, so what are some of the innovative approaches to protect the Arabian Gulf? This is just a few examples. For example, if you're trying to protect the coral reef and restore the coral reef habitats, 3D printed reef structures could be used. This is one of the innovative ways of doing the management. Also, using underwater structures constructed from recycled material, deploying them as artificial reefs. Another example is employing drone-based planting techniques for mangroves, dropping large numbers of seeds in a short time for the restoration programs. I think yesterday the gentleman from Aramco mentioned this as one of the options. So this slide just summarizes the benefits of implementing EBM approach, which is holistic, integrated, and multidisciplinary. It's very important, but remember that there is a cost to this, and without the sustainable funding, it is challenging. And this is the last slide. Basically, this is the research vessel, KFUPM research vessel. It's 55 meter. It's fully equipped, and we're really looking for joint research, utilizing the vessel and its equipment, doing regional studies, trying to understand more the Gulf ecosystem and its dynamics. And thank you.
Thank you very much, Dr. Faiza Al-Yamani, for the very exhaustive and informative presentation on ecosystem-based management. Our second keynote speaker is Engineer Saleh Al-Amri, the Chief Executive Officer of GCC Lab. GCC Lab is an independent company that provides professional, local, third-party inspection, testing, certification, calibration, professional training, international skill certification, and technical engineering services for all industries. Engineer Saleh Al-Amri holds a master's degree in electrical, electronics, and communication engineering from King Fahd University of Petroleum and Minerals. Let us all welcome Engineer Saleh Al-Amri.
One is for facilitating such very important technical platform to exchange knowledge and inviting highest authorities in the field. And second message for creating the GCC Lab, as maybe some of you know that GCC Lab was just an idea that was created and developed by KFUPM and then graduate me, otherwise I will be jobless. My presentation is just to elaborate about the laboratory roles in supporting and accelerating the energy transition towards green objectives. Of course, if you talk about labs, maybe people may think about a small room that has a certain small equipment. However, the international knowledge around labs is that they are science park that hosts very sophisticated facility for testing, and on top of that, they can provide technical services, standardization, development, inspection, audit, benchmark, technical studies, asset assessment, and management, and also to support R&D efforts. As you can see, the role of the testing laboratories, they are intermediate between the regulators of the different organizations and the end users, being an end user or manufacturer or service providers. So they are a third party, independent, impartial institutions that make sure that the regulatory policies are implemented and verified with the second or third eye that has no interest relative to the commerciality of the business. Just to jump into the conclusion about the role of labs in supporting climatic and energy improvement towards green climate is, first of all, to develop governance. And I think Dr. Faiza talks about the impacts and the importance of having the right standardization and policies that enforces the solutions towards energy and climatic solutions. So labs, they are a third party. Of course, those standardization and policies, they should be developed by a third party who has no interest in the business commerciality, as you know. And labs, they are usually the major contributor to developing the standardization activities for all technical associations. Secondly, the labs, they are also responsible to provide compliance management to ensure complete compliance and application and implementation of the policies that are set by the regulators from an independent point of view that is impartial and has no influence from any party. Secondly, they can also monitor the ongoing activities, projects, initiatives to make sure that they are doing the intended scope and they are monitored to achieve the milestones towards the final KPIs or the expectations, and ongoing audits, improvements should take place to help the organization to improve and see progress into their exercises. And also, as you know, the labs, they are the kitchen for research and development, verifying and qualifying new products, providing new solutions. And inshallah, we will explain some more activity that GCC Lab is providing in this regard. And the final maybe scope of the labs is to commercialize IBs in order to move them from just being an idea into something implementable and practical, and everybody can gain the benefit out of them. Of course, around and throughout all these processes, there's a lot of data relative to the climate, the equipment, the technologies, the certification and standardization that those labs are holding and activating in order to push the improvement forward and support the strategic directions of the globe. GCC Lab is one of the world's largest testing complex that was built, alhamdulillah, في الدمام, third industrial area, Modern 3, and it was built in a scalable manner so we can continuously expand in order to meet the demand and also diversify the sectors and the services to also fulfill the requirement of new technologies and directions that are always developing. It is an integrated operation built on around 170,000 meters square of space. It has 15 buildings that has hundreds of tests capability. We will, inshallah, put some elaboration, but it is multidisciplinary that covers energy, climatic, safety, environmental, etc. When it comes to the energy and climate, we are dealing with this issue in a very integrated manner. We established the Energy Innovation Center, which deals with the energy optimization and improvement for industrial and non-industrial applications. And Mr. Ahmed Asiri, he is the head of the center. He is also sharing with us his experience today, inshallah. And we have the Gulf Renewable Lab that covers the alternative energy solutions. We have also very sophisticated environmental lab that can provide analysis and support to the environmental gap analysis and improvement. And also we have very big, very huge electrical equipment labs that make sure that the products are safe, reliable, and efficient so we can contribute to the solutions and climatic mitigation. The lab was inaugurated last year, alhamdulillah, attended by His Royal Highness Prince Abdulaziz bin Salman and distinguished decision makers in the GCC. Of course, the investment is around 1 billion Saudi riyal. Alhamdulillah, the lab achieved all certifications internationally, regionally, and nationally. You can see the shareholders. They are the top leading companies in the kingdom and the GCC. We have very good mix of neutral agencies, end users, manufacturers. We have the big energy producers and energy consumers who constitute more than 80% of the Saudi market. So the solution is integrated, and we have all minds set to establish and support the climatic and energy solutions. Of course, we have categorized our business into 4 focus areas. First area is the testing and prototyping, which is initiated to make sure that products are viable, practical, safe, and efficient, and also prototyping so we can create a platform for everybody to initiate, develop, and test and qualify ideas. We also create a compliance management organization that can help to set standards and make audits to make sure the compliance is to an acceptable level, and we can trend and improve with organizations step by step, and also to certify people so they can be energy auditors, environmental auditors. They can be specialized in their field in order to make sure that the services are world class to the best standard. And also, we focus on the R&D and technical services to deploy latest technology to serve the purpose. Of course, we serve all disciplines. We exist now, alhamdulillah, in all areas in the kingdom, the main area, Dammam, Riyadh, Jeddah, and we have branches in Bahrain and Oman. We provide equipment calibration, which is important for measurement, as you know, renewable and environmental solutions, sustainability and energy efficiency, compliance, assessment, management, laboratory services, fire and safety services, benchmarking and operational excellence, and research and development. We deal with the sustainability in a very integrated system. This is a very self-explanatory sketch that was designed to show that those activities are integrated, overlapping, interactive. We start with laboratory testing by sampling and make quality checks. Secondly, to make inspection and auditing in order to make sure that the improvement is traced. And also we provide consultation and innovation to support technical improvement and R&D efforts. For the laboratory services, we provide site testing and impact assessment for the weather, for the sand. We provide also construction and material testing to make sure that the material are quality, they have the right quality and the right environmental design. Also, we calibrate and test equipment to make sure that they are safe and they are precise in making their intended objective. And also, we provide emission control and waste management for water and soil and petrochemicals. The second focus area is to focus on the standard regulation by ensuring compliance to sustainability, by creating the governance and try to manage the compliance by auditing and inspecting, by provide certification for people and for facilities, and also analyzing the auditing and provide feedback and action items for improvement. Also for the audit and implementation of strong governance, we have certain procedures that are standardized by studying the regulations, review the best practices, make very customized study for each facility in order to see what are the specifics and assess the risk and make a schedule and for action items and compliance improvement. Of course, this is the life cycle management procedure, starting with the design, execution, operation, and maintenance stage, and also in the decommissioning stage to make sure that energy, environmental, and climate issues are addressed and controlled. One important issue is to qualify people in order to do the right thing to the best standard. So we build on the academic qualification. Sometimes we have collaboration with the universities like KFUPM and Imam Abdurrahman bin Faisal in Dammam to support the curriculums by adding certain materials. We also qualify the organization and the personnel and provide on-job development testing and certification for people so they can be certified and recertified to do their work. Continuous improvement for the standardization, and we apply the normal and famous cycle by revising and updating, auditing, conducting benchmark studies, reassess risk, and improve the regulations and policies. The last but not the least, and this is maybe the core business of our presentation, is to work with all agencies to create a roadmap to deal with the energy, especially as one of the most influential elements to impact the environment and climate. So we develop a roadmap that prioritizes the energy and optimization action and try to start with the low-hanging fruit, the easy one, the one that has economics. This is just a demonstration of how we are approaching this issue. For example, if we have a goal relative to the CO2 emission and energy utilization, we start first with the energy efficiency. You cannot speak about any alternative if your system is not efficient. You cannot deploy alternatives to feed and supply non-efficient systems. So our effort is focused mainly on the energy efficiency as a priority one, and then you can move to the circular economy, and after that you do the fuel switching, and then you deploy the carbon capturing and renewable energy after that. Of course, the first one and second one, they are low cost, easy to do sometimes, and also sometimes they have a negative cost. You can gain a benefit out of efficiency and circular economy. So we consider them as priority number one. Fuel switching, they can provide up to 40% reduction of carbon emission if you switch and utilize gas against fuel, heavy fuel selections. Just to demonstrate more about the efficiency, we have three main objectives: is to innovate new solutions through R&D and technological solutions, softwares, then deploy and develop and deploy sustainability IBs. We have, alhamdulillah, in Saudi Arabia in general, from different agencies, we have thousands of IBs relative to the energy. However, the challenge is to move them from just being registered to be implemented and convert them into products that can support and help the KPIs when it comes to energy and decarbonization. And adopting new technology and best practices. You can see the efficiency optionality is distributed around different technologies. For example, the cogeneration. If you have practical potential to deploy the cogeneration to the thermal match, you can improve the decarbonization by more than 70%. And then you come to the other solutions, the heat recovery, the load management, the combined heat cycle, and the power recovery. We evaluated the potential around the efficiency improvement in the kingdom, and there is a potential of improving 25% of the whole CO2 emission. Hopefully, this is a priority for every organization, and inshallah, through such collaboration, we can convert this into projects and initiatives with the regulators and the end users. The energy efficiency potentials, we deal with the existing plants and also with the new design or the new project. We have three levels of energy audit. The first one is the quick energy audit. It is a high level. We can identify the potential, the KPIs, and we help the organization to set their targets. And then we can move to the detailed assessment. It will have to have in-depth review, engagement with the operation, studying the processes, and studying the potentiality of having cogeneration or different technologies. And the ultimate goal is to make ourselves ready for the ISO 5001, where you have the energy performance indicators, you have significant energy users. So now the level of the energy efficiency is becoming very structured and organized. And the new design, it should be easier than dealing with an operative facilities, but you can do the design, we can do the design review, initiative identification, we can help them to size the cogeneration, and work on the techno-economical evaluation so we can make the business case feasible with respect to the individual organization and also at the level of the nation itself. And also the energy compliance review, which is handled or governed by SEEC. It should identify the energy intensity and best available technology so it can be enforced by the design. In conclusion, I think there is a big role for the labs as a TIC, testing, inspection, and certification agency, to create governance, suggest governance to the regulators, and also to work to validate compliance ongoing with the operation and maintenance of different facilities. We can also, labs, they can perform energy and environmental audits and help organization to set practical and achievable targets. We can support efficiency endeavors at the supply and the demand sides. I think there is a big role to make the renewable reachable and available and cheap enough for the end users to utilize, and stop subsidizing the fossil fuels alternatives. Also develop unbiased decarbonization strategies as explained, and fostering the R&D and deploy viable IBs and convert them from just registration into something, product that can help and support the KPIs. Also, labs, they serve as a one-stop shop for big data and trending analysis. I think you know the importance of having big data when it comes to small equipment up to marine or solar map or wind map. This is very important to have a sustainable progress and development for product, for solutions. This is very important to the regulators, for the investors, for the research and developers, so they can direct their effort towards the most important and priority one of dealing with a very wide range of initiatives and challenges that cannot be dealt with an organization or a government. It should, in fact, enhance all efforts towards one direction. But the big data, it can direct us to the most effective solutions, and it can help us to trend the progress and see what is our effort and what is the future. I think this is the last slide in my presentation. I'd like to thank you for listening, and assalamu alaikum.
Thank you very much, Engineer Al-Amri, for highlighting the importance of quality testing platforms in supporting the implementation of ecosystem-based management, particularly in acquiring the required data for monitoring as well as handling big data science. Our next speaker is Mr. Mustafa Filimban, a coastal and marine environment specialist from the Saudi National Center for Wildlife. Mr. Filimban holds a Bachelor of Science degree in Physical Oceanography with previous work on air-sea interaction and net heat flux in the Red Sea. His expertise in the National Center for Wildlife involves coral reef health, assessment of seagrass meadows and mangrove forests, and their associated fauna and invertebrate organisms. Mr. Filimban is participating in research studies aimed at designing marine protected areas for conservation and sustainability of natural resources, with special attention on ecosystem restoration of most important degraded hotspots in the Red Sea and the Arabian Gulf. Ladies and gentlemen, let us all welcome Mr. Mustafa Filimban.
First of all, I would like to thank you, everyone, for being here, and the organizers for welcoming and hospitality. For me, it feels home, actually, being here once again in front of my colleagues and brothers, as I am an ex-KFUPMer, worked for 5 years in the Center for Environment and Marine Studies. Without any further ado, I would like to start with my presentation. As you can see, NCW efforts to achieve sustainable management of marine resources. So in this presentation today, I would go through the table of content, starting with introduction, going or passing by these titles to eventually NCW achievement in marine conservation. So in March 2019, the Kingdom used to have two commissions. One of them were Saudi Wildlife Authority. These two commissions get canceled, and instead we have now 5 centers or environmental centers. As presented, it's one of them, the National Center for Wildlife. So the overview of the NCW is the main agency responsible to develop and implement plans to address threats to terrestrial and marine wildlife, and to rehabilitate endangered species, restoring their natural habitat and ecosystem. So NCW is guided by its mission and vision. Thank you. NCW is guided by its mission and vision. The vision is to achieve a thriving and sustainable wildlife species in both the terrestrial and marine ecosystem. And the mission is to conserve and improve the status of wildlife biodiversity and ecosystem through comprehensive and effective program, as well as involvement of local communities to achieve sustainable environment and to create social and ecological values. The role of NCW, actually the responsibility of NCW is to conserve and rehabilitation of marine habitat and species, and creation of marine protected areas, as well as increasing public awareness of the importance of marine ecosystems and its associated species. All of these responsibilities targeting to manage the marine wildlife species and habitat so that they can continue to fulfill their ecological rules and be to benefit to today's and future societies. So NCW Marine Division strategic focus areas, conservation and under conservation and rehabilitation, we have marine habitats, mostly focus on coral reefs, mangroves, seagrasses, island, and deep sea. And under marine species, megafauna, sea turtles, dugongs, dolphin and whales, elasmobranchs, shark and rays, avifauna, of course, seabirds. And then monitoring, emergency response, under monitoring, inspection, coral reef check, satellite monitoring, and MPAs. Emergency response to oil spills, mass mortalities, marine vessel stranding. In this slide, I will speak about the Marine Division strategic objectives, which is sustainably protect and develop wildlife and biodiversity in marine and coastal environments. 2 is establish and manage protected areas and threatened species reproductive centers and their restoration in their natural habitat. 3rd, build a knowledge base on wildlife and biodiversity in the kingdom through making field surveys, specialized study, and of course, databases that will be available to relevant stakeholders. Raise awareness on wildlife across communities through outreach, cultural, and media programs. Promote economic diversification by contributing to the development of sustainable ecotourism and the utilization of genetic resources and ecosystem services. Promote cutting-edge research and innovation in wildlife conservation by engaging with other universities and local and international research centers. So the mandate of NCW, Marine NCW. The mandate of NCW is to conserve and develop wildlife species and habitat in the Kingdom of Saudi Arabia. This is achieved by implementing a suite of strategic actions across various management levels, which is research, policy development, emergency response, and finally, habitat restoration. Starting with the research as a first element in the strategic actions, some of the key projects are as presented: Red Sea and Arabian Gulf Marine Megafauna Survey, Shark and Rays Assessment, Biodiversity Assessment in the blue holes of Farasan Banks, and all of other projects are around research and surveys. It's only to have a better understanding of ecosystems and marine wildlife species and to fill the gap of the missing aspects of the data. Moving to policy development as the second strategic action, NCW Marine projects support enacting the executive regulation to, in a narrower scale, the protected areas, and in a broader scale to manage the marine and coastal environment. And of course, the project contributes to raise the public awareness in sustainable development, sustainable fisheries sectors, ecotourism sectors, environmental education. Some of the key projects that aim for habitat restoration are presented in this slide. Restoring an area of 1 kilometer by 1 kilometer of coral reef under ideal condition. Disposing of discarded fishing net both in the Red Sea and the Arabian Gulf. And of course, this project contributes as well to raise the public awareness by showing the amount of extracted fishing gears out of the sea and to illustrate the damage and the impact that it may cause. Third, NCW emergency response plans serve to create an organized and systematic series of procedures to be followed in case of emergencies. To date, NCW has developed 3 emergency response plans: Crown of Thorns response plan, which has 2 broad goals. The first one is to monitor cod's population across the Kingdom of Saudi Arabia reefs to prevent potential outbreaks. The second goal is to respond rapidly and effectively to prevent coral loss and reduce extent of COTS outbreak. The second response plan is oil spill. The goal of this plan is to provide a clear direction, guidelines, and procedures in the treatment of oiled wildlife and coastal and marine habitats in the event of oil spill. There are other projects still under development that also contributes to oil spills response plan. Moving to the third one, sea urchin crisis response plan. So within 24 hours, NCW has corresponded with key research and government agencies. We received comment from Center of Environment and Marine Studies, KFUPM. Thank you for that. Of course, to complete this plan. So the plan is divided into 3 phases. The first phase is to investigate and examination. The second phase is about determination of extent and reach. The third phase is about wide-scale removal of infected organisms and additional responses. Continuing with NCW Marine mandate, the area highlighted with the green color are proposed marine protected area, while the red ones are active marine protected area. So the current status toward the national target of marine protected area is 6.5%. The target broke down into two phases. First phase by 2025 to have 24% coverage of the territorial water in the kingdom as marine protected area. The second phase ends by 2030 to have 30% coverage of the territorial water in the kingdom as marine protected area. In this last slide, as presented, NCW achievement, NCW accomplished to assess or accomplished the assessment of the status of more than 450 sites of marine habitat and its associated species, accomplished to the development of inspection and monitoring plan along the coast of the Red Sea and Arabian Gulf, the development of conservation and protection strategy planning for a marine protected area, development and implementation of plans and protocol to ensure the sustainability of the environment, development of rehabilitation programs to restore the function of the ecosystem. Thank you. That's it.
Thank you. Thank you very much, Mr. Falimban, in emphasizing the leadership taken by the National Center for Wildlife in protecting and conserving the marine and terrestrial environment of Saudi Arabia. Now we are going to take a short break. We have two more exciting talks after this break, so we ask you to go outside to have some refreshments, and please be back by 10:35. 10:35 sharp, yeah. We'll have 10-minute break. Yes, Mike. We would like to invite the audience to please return to their seats. Kindly invite people from outside to please come in. We will begin our program shortly. Yeah, okay. We would like to ask the audience to please occupy the front seats. Ace, please occupy the front seat, and Ray also. Kindly occupy the front seats. Hello? Can we begin? I will start. Do we have a cue from the streaming? Kindly occupy the seats in front. Okay. Ladies and gentlemen, welcome back to our session. Our third keynote speaker is Professor Arild Folkvord from the University of Bergen in Norway. Professor Folkvord has held a full professorship position since the year 2000 in fisheries biology in the University of Bergen in Norway. He obtained his Master's of Science in Marine Biology in 1985 at the University of California, San Diego, Scripps Institution of Oceanography, and his Doctor of Science at the University of Bergen in Norway in 1993. A major part of his research has been experimental studies relating to recruitment of fish and fish aging studies, for which he has led and participated in strategic university research programs. He has participated in several national and European Union-funded projects and networks, and served 6 years as the director of the Nordforsk-funded Nordic Marine Academy, which provided international PhD courses and workshops. He is an active member of the European Union-funded fish aging networks of IFAN and Takadar and related EU-funded research projects. Ladies and gentlemen, let us all welcome Professor Arild Folkvord.
Hello, you can hear me? First, I would also like to thank the KFUPM for inviting me and the organizing committee for making this such a great event. I will start by giving, I need to do You have to put down, okay. Yeah. So. Wait, sir, wait. Okay. A little bit about my background is given already. Regarding definitions, thanks to the nice talk by Dr. Al-Yamani, I will not have to dwell too much with the details of the definitions of ecosystem-based management, but I will mainly deal with the assessment part of management. And I will talk a bit about fisheries assessment and management, and I will then have specifics about habitat specifics and coastline implications. Fisheries management and inputs and insights, mainly from Norway, and aquaculture management and status and lessons. And then I'll move on to some specific challenges from the high latitude ecosystems and data requirements that's also been mentioned here by this talk, which I also would like to stress, and then have some concluding remarks. So we are here, Daran, and I'm from Bergen, Norway. And I will speak a bit about the systems up north, in particular the Barents Sea. The Barents Sea is a shelf area, very productive, important fisheries grounds, and also recently in use for petroleum activities with oil production. It's sustained by warm currents from the North Atlantic coming in from the southwest and has inputs from the polar regions with the slightly colder waters. And it's a system that's co-managed between Norway and Russia. So as you mentioned in your talk, fish assessment is really just a part of the bigger picture, multi-species stock assessments, ecosystem-based fisheries management, and then ultimately ecosystem-based management. And my point of putting up this slide here is really to say that we should not forget the need for high-quality stock assessments still, although they are incomplete in an ecosystem-based management perspective. And this also goes for all the other activities and data inputs that we need to do a proper ecosystem-based management. And we could divide these different activities. I do it in a slightly different way, talking about extraction and production of marine resources through fishing, aquaculture, mineral extraction, petroleum activities. We also have the preservation and conservation of natural conditions, where we want to take care of biodiversity and also mitigate any pollution effects. And then we have all the human activities that come on top of this with tourism, ship traffic, transport, habitat access, and utilization, as well as coastal land use. So, what do we do in Norway? Here's a map of marine and terrestrial reserves in Norway. And historically, there's been more reserves on land. And that's sort of strange since Norway is really a coastal country. The exception is up north. You can see in the islands of Svalbard, where large areas are now protected, both on land and at sea. And this is mainly due to two reasons. One is there's less people living there and less conflicts by implementing such a measure. And also, it's a high Arctic region, which is very vulnerable. On the other side, if you look at here, now something more related to the activities in this region, to the right, the petroleum activities, which is offshore activities in Norway. You can see these are active production sites off the coast of Norway. These are in operation. And then on the middle slide, you see planned field offshore wind projects. And they are co-locating, actually, and that is to reuse already existing infrastructure to not have to implement new sites for new activities. And also, having these wind parks offshore, there's a lot of wind out there, but also there's less conflict with human interactions, like you will have on land in our area. Unfortunately, they don't overlap with our reserve areas, so that's of course, a necessity. If we look at the bigger picture of regions, I mean, here's Norway with its 12 nautical mile coastline around the mainland and the islands, and also the 200 nautical mile limit. And in fact, there's an area there which is not covered, which is in international waters. And international regulations in these areas is extremely important, because if it's any free activity, that would cause problems in the neighboring areas. And here again, there's two more slides showing the interconnectivity between nations and in so-called international waters. You can say that the oil structures, oil installations in Norway, they have pipelines going to the mainland, but also to England, to Denmark, to Germany. And of course, very rigid and good regulations need to be in place between countries to have these installations in place. This is also in the case in the middle here, where actually every little dot you see is a vessel that has been trawling, bottom trawling, and it's been recording when it's been in operation. And the point about this is that, I'll mention later, is that the dots are not randomly placed. The fishermen know where to go. The second is that they actually operate both in national and in foreign waters. So again, the need for good international regulations is essential. One specific example for that is now that's come up recently is the Norwegian government's decision to explore the possibilities of extracting nodules up to the right or minerals in the sea. And here along the mid-Atlantic ridge. At this stage, just investigations. However, these areas are really unique in the sense that they house unique life forms. As you can see to the left, these smokers. And these are biological systems that don't rely on photosynthesis, but they thrive through chemosynthesis. So there's a really strong need to protect these areas and before we do too much damage on these places. And it's actually a highly controversial issue back in Norway at the moment. Regarding other resources that we discover, Here I've plotted, here's plotted locations of deep sea corals that we discovered the extent of in rather recent years. These coral reefs are highly vulnerable to physical damage caused by either fishing or petroleum activities. And actually, they were discovered through our petroleum activities in the sense they were, through their monitoring of where to have the pipelines, they had extensive geological surveys and also video monitoring, and discovered the extent of these underwater deep sea corals. The good news about this, though, was that once they were discovered, the management was able to very quickly establish marine protected areas safeguarding some of these major coral reefs. So a very important case. Well, back to the Barents Sea, and if we look at the middle here, it's the Arctic Marine System. What we are at present implementing is a series of integrated ecosystem assessments, and in this blue box here. And it's not only the status of these different assessments, but if you look to the left, you see there's a lot of pressures that are on this ecosystem. And these relate to both climate change, fisheries, oil and gas, shipping, and pollution. So there are different management options for all of these pressures. And at the current state of the Barents Sea management plan is to have an integrated assessment both of the state, which really requires good data, as was mentioned, but also management options for the different pressures that are coming in. So here's a picture of where you see the extent of the Barents Sea to the left and regional waters here. And you can see that these are depicted in more or less the same scale. So you see that these are comparable, not too far off in extent. And if we take the different systems, I mean, the Barents Sea is a few hundred meters deep, the Gulf of Arabia, 100 meters, Gulf of Oman, 3,000 some meters. And the special case of the Red Sea, which if I'd not known the scale of it, it would have looked like a little fjord to me. But it's huge and extensive, deep, but has a rather narrow sill and all the issues that comes with in terms of water exchange. And just to give a sort of outline of that, I mean, I've depicted a little fjord. Well, actually, it's the biggest fjord you have. It's the Sognefjord. It's 200 kilometers long in Norway. And we have many of those. And you can see they're very serrated, so there's a lot of coastline there. And they have their own issues. Here's a picture of a fjord, very steep sides and very deep. And the Sognefjord is 1,300 meters deep. So in a sense, that gives us both opportunities and challenges in the sense that we have a sort of deep sea environment inland, which we can easily study. On the other hand, it's hard to get across with our vessels because this fjord is many kilometers wide and, as I said, 1,300 meters deep. So, but anyway, there's a huge amount of coastline covering this. And just to remind you that when we measure coastline, it all depends on the scale of measurement. So around England here, if we measure with a very broad scale, we will get a smaller coastline compared to if we have a finer scale. So just keep this in mind. But in that sense, we could say that when we talk about useful metrics, the offshore areas are useful, but in terms of coastline, the inshore coastline itself is a good metric. And how is it with coastline? Here are two sources of statistics that have covered the coastlines all over the world: the World Factbook and the World Resource Institute. And they, depending on the scale they've been using and whether they include all the islands, and Norway ranks as number 2 or number 7 in the world, which is, I think, surprising for most of you. Saudi Arabia, in spite of its large landmass, has a much smaller coastline. And to the very right, you see the statistics of coast versus landmass. So you have a metric in Saudi Arabia of 1.2, and Norway has 200, which is good news for Norway in the sense it gives us possibilities for using our coastline. But on the other hand, coastline is more precious for you, which means that you should have special attention to take care of the coastline you have. So the bottom line is really the different coastline metrics really would suggest different management strategies and priorities. Now, back to fisheries, which is my field. And here's a cartoon to the left showing the situation from the 1900s, where we had one vessel, lots of fish, and then at the end of the century, lots of vessels, one fish. This is not entirely correct, and the picture to the right is a recent picture from Norway with a big purse seiner catching loads of fish. So we can still have the situation where this is possible. But this does really require proper management. And just as a metric here, I could show you the line, the red line here, shows the trend in number of fishermen in Norway over time. And it's been steadily declining. And the upper bars and the shaded area really shows the catch they have been catching, which has not changed that much. So the green line really tells you that the number of fish per fisherman has increased dramatically. From a management point of view, this has been beneficial because the amount of subsidies that has been required to the fishermen has dropped dramatically, virtually to zero. The fishermen are making enough money by themselves. They're fewer, they're wealthier, and they're making good money. So, but anyway, this has political implications because, depending on where you live and where the fishermen are, that is in the recent debate whether you should prioritize the bigger vessels or the smaller coastal vessels. So that's a management issue that's a hot topic at the moment. So, illustrating the management value, I give an example of one species, that's the Norwegian spring spawning herring, to the left, sorry. And it's a pelagic schooling fish that spawns along the coast of Norway, along the red dots. And the larvae drift into the Barents Sea, the light blue area, where they stay for a few years, and then eventually migrate out into the Norwegian Sea and come back to spawn. And if you look at the right graph, at the line, this is the catch number. And you can see at the late 50s, beginning 60s, the optimism was sky blue, and the catches were phenomenal, up to 2 million metric tons. This was not, however, a reflection of the state of the fisheries, or the fish, because the bars, which is the population size, actually had a dramatic collapse. So it was a clear-cut case of overfishing, which led to a 20-year management moratorium on herring. This was an extreme measure, but it was needed. And you can see that after this moratorium, the herring stock rebuilt and is back up to this, more or less the same numbers, with an average of 1 million metric tons a year. So this lesson cost us, I believe, 20 years of 1 million metric tons a year. And how did this happen? Well, this was happened during the period of technological innovation, where sonars and purse seines and power blocks enabled the fishermen to be much more efficient than they used to be. And the management underestimated the stock size used on the standard catch per unit effort metrics. So they thought there was a lot of fish because the new vessels, they were effectively catching what was left. But as one scientist said, you have one purse seiner catching the last school of herring. So, you got to have other type of data to manage these kind of fisheries. So now we're down to the regular management, and it's an annual regulatory cycle. And in the red here, it says that it's really the ministry that decides the final call. But before that, there are important events taking place, and I've highlighted the research cruises, catch sampling statistics that I'm part of. And later on, there is discussions with the international fisheries organizations, neighboring countries, and it comes back through stakeholder meetings, and finally the ministry decides. And this is the regular cycle that will take on and go on yearly for all species. So, the management objectives, how do they vary? And in Norway, they set up a very simplistic list, and there's 5 different categories, and there are different management objectives depending on the type of a stock. And if we look at the first one, economically important ones, you know, the long-term, the management objective is really to obtain the optimal long-term economic sustainable yield. I mean, you know, try to get as much out of it as possible within a sustainable framework. For then, you have some stocks where you don't have that much information, and you got to lower the risk a bit, and you cannot search the optimum. But you still want to aim at relatively high, if possible, stable long-term yield. But you cannot optimize as much if you don't have that kind of information that you need. And for stocks of low economic importance and non-commercial species, the objective is really to ensure biodiversity and ecosystem function. So there's not so much direct economic incentives from the management side for these. And in the case we have alien species, actually the management objective is to reduce that stock. So these different priorities are used in management. And in the following slide, I'll have a rather chaotic slide where I'll show to the left here a list of species, and don't bother with the details, but in the red to the right is actually the different management options that are decided for the different species. And the greens and the reds are really, everything is okay, green, okay, red, caution. So if you have not enough data, or if it's in poor condition, typically you will end up having a management objective that reflects that. So this is actually done for all species. And my point earlier was that it has to be done in a proper manner for all species. So how do we get the data in Norway? Well, one of the ways is to have a reference fleet. A reference fleet is actually fishermen that are commissioned either by pay or by extra quota to collect data to catch their fish, but with the aim of enumerating entirely the whole catch, and no discards, and measuring the fish. As an example here, there's 2 research vessels that have been going out in different seasons, and in this case, they were estimating the biodiversity, fish diversity index through these 4 seasons, and you can see they differ a bit. So this is a type of fisheries-dependent data, because the fishermen, they go where there's fish, and they go out when there's fish to get, so it's not random. But the data they bring in is essential for fisheries management. The other alternative is to have fisheries-independent data, and that's through surveys. And a very good example of that in our waters is the Barents Sea Ecosystem Survey. That's actually combined of 5 different surveys that was merged into the BESS, Barents Sea Ecosystem Survey. And here you can see the transect lines for the different vessels that's undertaken by Norway and Russia that covers the entire Barents Sea. It's an extensive program that goes out over 2 months period in the autumn. Here they investigate the temperatures conditions, the plankton conditions, the young of the year O group fish, the free-swimming pelagic fish, bottom-living demersal fish, bottom-living animals, seabirds, marine mammals, and their interaction through diet studies, as well as looking into pollution and marine litter and food safety. This is extremely essential data for the proper management. So as an example of a management case, I thought I could bring a global one that's also of interest here, because this is published by workers from KAUST and others on the large mesopelagic fish biomasses of these peculiar fish mesopelagics living in the twilight zone. And there's ample examples of high densities in local waters, in the Arabian Sea and also in the Red Sea. The point about this was that the estimated number of fish, or amount of fish, was 10,000 million metric tons, which was 10 times the global fish biomass previously estimated, as far as I understand. And this is a huge potential resource, but how should we deal with it? This is in international waters, so you need to be careful. Global management is really needed in this case. Moving on to aquaculture, and here Norway takes advantage of the infrastructure through the coastal areas. We could have cost-effective technology benefiting from coastal infrastructure and environmental conditions, but there's no free lunch here either. And coastal planning and management is highly essential in order to have this salmon industry. And here's a picture of where we have salmon sites, salmon production sites and other sites. You can see there's all over the coastline in Norway. And if we zoom in on this area south of Bergen, you can see that lots of sites. In the inner parts of the fjords, there's not so much, and that has to do with the fjord recipient capacity. They cannot take so much organic inputs. But we have developed a traffic light system in the management where we have coastal zones that are more inherently linked to each other than between locations. And so this traffic light system is really giving a regional planning depending on farm abundance, salmon lice abundance, which can cause direct damage or even the sea transfer, the local wild salmon status, the recipient capacity, and it's based on oceanographic currents and interconnectivity. And here's just a quick diagram showing to the left of the red the data inputs, lots of data input, and then the blue, the modeling. And this ends up in a traffic light graphics where the green states that there's going to be less than 2 salmon lice per salmon on average. On the red, more than 6, and that will have consequences for more or less production. So just a little bit about high latitudes again. 22nd of December in Norway, up north, we don't have too much daylight. Up in the northern parts, the sun doesn't get up above the horizon. That's the bad news. The good news, in June, we have 24 hours of light. And that gives us, you can see on the right, a 24-hour difference in annual light conditions. Extreme seasonality. I've depicted Norway and Saudi Arabia on the latitudinal scale there, and you can see you have much less variation. So the light conditions are as challenging as temperature conditions in many ways, and we need to take it into account because the seasonal timing is really important. And in terms of high latitude, here's the Barents Sea again with the oil production operational units in color and the licensed areas in gray. And you can see we are up to 74 degrees. And just to give you a picture of how far north that is, 74 degrees south is solidly on the Arctic continent. So we are really up there, high latitude. So life at the edge, under ice edge, is extreme. And to the right, you can see that it's a very productive area with nutrient inputs and light coming in at the ice edge. And it's very important for many species. But the ice edge is really seasonally and annually varying in location because it's drifting and melting and reforming. And it's, as been mentioned yesterday, very subject to severe climate change effects. And also, in terms of marine traffic and petroleum activities, there's huge implications of the occurrence of ice, as we all know. So I had the pleasure of going on a cruise in October from 76 degrees north to 82 degrees north with this ocean-going Kronprins Haakon vessel. It can break through 1 meter of ice, and you can see the trailing path we have. And they had visitors coming to the boat, and we were busy in the inside sorting fish and measuring. And to the right there, I'm slightly overwhelmed with all the catch of the O group herring that you in that one catch. Too many to count. So basically, we need all these data for the knowledge-based assessments and managements. We talked about GIS data, geological surveys, seabed coverage, and video. And I mentioned fisheries-dependent data and independent data. But I would very quickly go through the need for time series and environmental data, and fish otolith and fish airstone archives for historical comparisons, DNA data for biodiversity and management. So the otoliths, as we see here to the left, a tree ring to the right, they're the same. We can age them. The good thing about the otoliths is that they stay for a long time. This otolith here is 6,000 years old, and then you can still count the rings and estimate the growth. The other aspect is the genomic observatories. I mean, I've listened to good talks here and posters where they're using eDNA. And I would just say that imagine if we had eDNA data from 50 years ago available today. What a beautiful data set, a gold mine that would be when we would do our assessments. And let us not miss that opportunity to do that now, because we don't want our kids and kids of our kids in 50 years to say, it would have been nice to have. So we should really get out there, and no need to delay the DNA sampling. So very quickly to conclude, I'm slightly over time, sorry. Sustainable management will depend both on the science and the policy. And key scientific data and information is needed to provide knowledge-based assessments and management. And sound politics and management will ultimately make the proper decisions. I would say, protect the areas before it's too late. And do we have the relevant data before we make our actions? And collecting baseline data to make informed decisions is really, really recommended, although it is costly. And this includes the ones I have mentioned. And I would say the precautionary approach towards sustainability is key in the absence of data and knowledge. And that should motivate all stakeholders to be willing to chip in to provide the basic data. Thank you.
Thank you very much, Professor Folkvord. Please take a seat in the panel. We are very, Dr. Folkvord, Dr. Arnold, please sit in the state. We're very glad to know that although Norway's very complex environment, there's hope for establishing ecosystem-based management as long as we sustain data collection with proper data quality. So the last but equally important presentation will be delivered by Associate Professor Edison Roy Macusi from the Faculty of Agriculture and Life Sciences from the Davao Oriental State University in the Philippines. Professor Edison attended the PhD program in Fisheries at the Wageningen University in the Netherlands and Master of Science on International Studies of Aquatic Tropical Ecology from the University of Bremen in Germany. Professor Edison's research lab is currently working on fisheries catch assessment of various municipal and commercial fisheries in Mindanao, Philippines, to be able to make an updated information on their catching methods, fishing gears used, and fishing locations, as well as impacts. His research team is also working on climate change vulnerability, adaptation, and resilience of coral reef fishing communities to be able to help develop programs that can address their economic situations in partnership with local and national government units. Let us all welcome Professor Macusi.
Good morning to everyone. I'm very glad and I'm very honored to be here with you today. And thank you so much for inviting me here at KFUPM and in Saudi Arabia. This is actually my first time in Saudi Arabia. So let me present to you our study. It's a part of our study. This is actually funded by the government. So it's funded by the Philippine Council for Aquatic Research. And this is a study about the closed fishing season that was applied in the Davao Gulf. It's one of the rich fishing grounds in Mindanao. So let's begin. So closed fishing season is a policy that is aligned to the national government's program for fisheries management. So closed fishing season is a policy that is really aligned to the national policy program of the government, mainly because we're trying to conserve what is left. So I think for the previous fisheries governance or management that was conducted in the Philippines, if I look back, like way back in the 2000 and 1980s, 1990s, there were already literature saying that it's overfished, it's depleted, and during our time, we also have the same. And therefore, we think that as Professor Horton mentioned before, there's an emergency. So we also think that in our case in Mindanao, there's also an emergency to really help the fish stocks to recover. So unlike data rich countries like Norway, like what Professor Ariel mentioned, in the Philippines, we struggle with data. So we always start from the scratch. So we start with survey among the coastal fishing communities. So closed fishing season really hopes to achieve, to stop the decline of exploited fish stocks and protect its habitat from during spawning and breeding period. Recent areas where it was implemented includes Zamboanga Peninsula. So this is a peninsula which is rich with sardines. About 80% of the sardine production in the Philippines come from this area. And the previous 2010, 2011, there was a catch decline. And all the commercial fisheries sector, they urged the government to do something with the management. Because sardines in the Philippines, it's like bread, a daily bread. So it's really a very important fish for a lot of common Filipinos. So what the government did is that they immediately commissioned a study, and for about 1 year, they came up with a policy that banned fishing from November up to February the following year. So there's about 3 months of fishing ban, and just 1 year after that, they saw an increase of the fish stocks of the sardines. Because of what happened in Zamboanga Peninsula, the government was encouraged to apply the same method to the Davao Gulf. So in Davao Gulf, there were also studies, like way back in 2013, in 2012, showing a decline in the small pelagics. Therefore, in 2014, what the government did is to implement a closed fishing season. So now here we come in 2019. After almost 5 years of the implementation, there were no assessments regarding the management, whether it was successful or whether it was documented. So our study entered during this time. So closed fishing season as a policy is really important, but in terms of conservation, in terms of monitoring, I think it was not monitored intensely. So our study has the following general objectives in this case. So it's really to assess the impact of the closed fishing season, and then to determine various factors that influence its implementation or the success factors, and then to explore possible impacts of the closed fishing season in terms of fish supply in the main commercial markets of the Davao region, and to compare the distribution of the fishing effort during closed and open season in Davao Gulf. So these were the areas, the study areas. We have about 6 study areas. So that's Davao City, Lupon, Governor Generoso, Santa Maria, and Malita. So the Davao Gulf is about 3,000 square kilometers. So it's a big area. And we use this method of studying, again, because we do not have a long-term data set in our hands. So we did interviews with the fishers, and we did focus groups also as a way to validate it, and later to do some in-depth interviews in the markets. With regards to the use of GPS trackers, we wanted to know or to find out where fishers are going during this time. So there were a number of respondents. We have 229 for the study that we did regarding influencing factors that influences their catch, and then about 150 for the study on the impact of the closed fishing season on supply. And then we did some analysis with selected quantitative data, and then we mapped the GPS that we got. So the mean age of fishers is around 43 years old, so they're still relatively young and range from 18 to 74. The number of years that they stayed, they rarely migrate, so it's about 35 years. The fishing experience of 25 years, but it ranged up to 64 years. And the household size was actually big, so that's 6. And it can go as high as 13. In terms of cost of fishing operation for one fishing trip, that's 357 pesos or about $7. So one complete trip is 9 hours, and it can also range from 1 to 24 hours. A normal catch per trip is about 7 kilograms, but if they're lucky, as they mentioned, then they get 29 kilograms per trip. And the revenue per trip is about 918 or almost 1,000 pesos. That's about $18. So in terms of the relationship between CPU and fishing characteristics, CPU was highly influenced by the number of years fishing, the revenue, the proportion of catch left for the family. We think that the number of years has something to do with the knowledge of the fishers of the fishing area. And in terms of revenue, their economic motivation of fishing, and the proportion catch for their family. And fishers with longer fishing experience, we found out that they have higher CPUEs. And the revenue of fishers follows a J-curve, and fishers usually get higher profits. So in terms of factors, considering the influence of that influences the closed fishing season, so we have fish price. So during our analysis, we found that fish price was motivation. So they also know that daily fishing trip will be affected, but the fish price in terms of the fish being sold in the market increases. So there was an economic motivation for the fishers. And then membership of organization and awareness, this was also important. And this has something to do with the flow of information, because in the Philippines, if you're a member of a fisheries organization, then information comes from the national government and then towards the organization, and then the organization informs the local fishers. So being a member of an organization is important. We also found out that for a successful implementation of the closed fishing season, there's a need for coordination with the local governments, awareness of the campaign, and there's a need for multiple agencies together, like the Navy, the Coast Guard, and the local government. So this is a graph for in terms of market supplies. So in the market, for most of our vendors, they actually support the closed fishing season, although they really know that for them, their support is because this can increase fish abundance or fish stocks later. And then for them, they think that it's because of the law. And 9% of them mentioned that this will support their livelihood. In terms of the effect of the closed fishing season with delay or lack of fish supply, again, they understood that this will decrease the fish supply, and then this will increase their fish price. But during this time, they source their fish from neighboring cities. So this is General Santos City, that's maybe 200 kilometers away from Davao City. So we also have other areas, far-flung areas like Zamboanga and Surigao that tries to supply during the closed fishing season. In terms of change of fish species being sold, most of the vendors, they do not want to change the fish species that are being sold in the market. And there's a high demand of fish during December. So in terms of when we check out whether there's a difference between the catches, total catches during the implementation of the closed fishing season and then the open season, we found that catches for the small-scale fishers actually increased after the implementation of the closed fishing season, while in the case of the commercial fishers, this actually decreased. In the Philippines, we differentiate between small-scale fishers in terms of boats, boat tonnages, like 3 gross tons below, and all boats that are beyond 3 gross tons are considered commercial fishers. And we do not allow commercial fishers within 15 kilometers from the shoreline. So usually we do the analysis like this, we separate the two sectors. And in terms of market flow of goods, we found out that we separated the small pelagics, the large pelagics or tunas, and then the reef fish. And most of these, for the vendors, they add about 2 times, 3 times, and 4 times, and even 6 times of the price, the original price that was sold by the fisherman. So this is regarding the fishing effort distribution. At first, we mapped this regarding the local ecological knowledge of the fishers for the Davao Gulf. And then we compared it to the GPS tracks that we got from the fishers. We think that the 2 areas where we have Lupon and Governor Generoso, it can reflect or it can support the map. But since we have a few data points, then we gathered more and we asked for more fishers to be enrolled in the GPS tracking program. So this is the case for the GPS tracking program. We have in Samal, that's the small island, that's number 5. So Samal Island, it has bagnet or a commercial fishing that's allowed in the area. Our commercial fishers in Samal has a special arrangement with the local government of Davao City and Samal that they can actually fish within 5 kilometers of their coastline. Although it was supposed to be prohibited because their boats are bigger compared to 3 gross tons. We have Malita and we have also Governor Generoso. So the intensity of fishing is actually going beyond 10 kilometers at almost 20 kilometers within the area. So the small-scale fishers, they are not only bounded within 15 kilometers, but they actually move beyond. And during closed fishing season, if we look at the Samal Island, that's number 5, the fishers actually stop fishing. But for the small-scale fishers, they continue fishing. So that's number 6, number 2, and number 1. That's Malita. And number 6 is Governor Generoso. And then after the closed fishing season, then they start again. In terms of data points here, after closed fishing season, there are less fishers that are involved, mainly because it's the northeast monsoon in the Philippines. And northeast monsoon from October to March is actually wavy and heavy raining. So, and sometimes also we have super typhoons that come from time to time. So this is in terms of monthly analysis of the GPS tracks of data. So this March, April, May, June, July, August, September, October. And again, for all the data tracks, it seems to show that most of the months that are intensely fishing is from March to June. And then afterwards, we got smaller or less intense fishing. So this is for November and December. We really have less intense small-scale fishing activities during this time. Again, we think that it's because of the northeast monsoon and the typhoons that visit the Philippines, especially down south in Mindanao. We think that 10 or 20 years ago, typhoons were not really visiting that area in the Philippines. So there was a change that happened. So this is in terms of the boat activities. We found that between 0 and 1 kilometer, when the speed of the boat is 0 to 1 kilometer, usually they're fishing, and beyond that, they're actually moving. So in terms of distance traveled, so the averages are there. So they're actually, in terms of average, they're within 14 kilometers, 13 kilometers, and 11. And for Samal Island, that's 3 kilometers. So it's just very nearby the near shore. So to sum up our studies, multiple factors are really involved in the decline of the fisheries. So there's again, the small-scale fishers, they blame the commercial fishers in the Philippines. They also blame the agricultural and chemical waste that are being thrown, because near Davao City and then at 2 adjacent cities, they have their banana plantation and mango plantation, and a lot of the waste are not really treated when it's thrown to, when it's dumped to the ocean. So fish price, daily fishing trip, awareness, and membership to an organization are variables that are influencing the implementation of a closed fishing season in the Philippines. And GPS tracking helps to provide an overview of the intensely fished areas. So at least we can validate with regards to the marine protected areas that are nearby, whether fishers are actually fishing within those MPA areas. Implementation of the closed fishing season together with effort control measures will facilitate fisheries conservation. We think that it's impossible to have a successful closed fishing season without effort control measures. Thank you for listening. So this is the output from our project.
Please. Thank you very much, Dr. Edison, for the very informative presentation of how Philippines is coping up with data poor situation, but we're doing our work. Thank you. May we invite Engineer Saleh Al-Amri to join us on the stage for the panel discussion. And we have until 12 noon to do the panel discussion. So on behalf of the organizers, I would like to thank our guests and speakers for the information you provided to us. And the panel discussion is now open, and the mics are there in the audience. So whoever wants to ask a question, please raise your hand. And please provide the mic. We have one question here.
Thank you. This is Ahmed Al-Ghamdi from the National Center for Vegetation Cover. My question to you, Arlid, thanks for the very informative presentation. You mentioned quickly about environmental DNA. I'm not sure, can you elaborate more about this approach? Here in Saudi, as far as I know, we are doing the let's say DNA sampling for the plant species, doing the DNA sampling also for some of the endangered animal species, also for the microbes, for especially bacteria and algae. But I'm not really sure about the environmental DNA. Can you elaborate more about this approach? Thank you.
Hello? Yeah. This eDNA approach is really new to me too, in a sense. I mean, and the initiative I was mentioning is an EU initiative where they're going to fixed stations, selected stations across Europe, and they are doing repeated sampling over the year and over years. So the idea is to have a map of DNA signals taken from the water. Because the animals and plants, they shed some tissue, and that will eventually leak DNA into the water. So by taking water samples, you will get DNA signals. And the benefit of going to specific sites is to get, let's say, a historic change or a pattern that's over what is happening. So, and in our case, University of Bergen is involved in this EU project, some colleagues of mine, and they're having sampling site next to the Marine Biological Station, where they, over time, every month, they go out and they will see fluctuations in which DNA signals, which animals and plants have been there or will be detected. And the point is, if we'd had something like this from 50 years ago, we could have contrasted that against what we have today. And we can see really the impact of, and change in biodiversity in a very powerful manner. So it's really I would say this kind of data is a gold mine, having that data, and it never goes out of value. So, and not only for biodiversity, but I'm now starting up with a project with a colleague of mine where we are looking at different herring stocks, because they have different DNA. So the aim is to see how they fluctuate in a certain area, the various components of herring that spawn at different times of the year. And that will give us a picture of stock structure, which is useful for fisheries management. Again, this kind of data, the DNA data won't go out of fashion. I mean, it's there to stay. So, yeah.
Yeah, I have a question. Roxy Call from Indian Institute of Tropical Meteorology, Pune, under the Ministry of Earth Sciences. So my first question, I have a set of questions. My first question is to Ariel and Edison. And you have shown beautifully how, in the Norwegian seas and the Philippine seas, how you can manage the fisheries and probably the ecosystem as well. Now, my question is, when you come to international seas, I would like to have just your opinion on, how to manage that. For example, I have a story from the Indian Ocean. A few years back, I explored, the climate change signals and their impacts on fisheries in the Indian Ocean with the data from the Indian Ocean Tuna Commission, and that showed. So they had data from the 1950s on, and it showed a huge dip around 50s, 60s, and that was largely due to industrial fisheries, and then it never came back to that proportion. And in between, it has always been difficult to explore and investigate the climate signals on these fisheries variations as well. Yeah, and one aspect that I found is that I don't know whether there are strict or stringent international laws regulating fisheries in the larger Indian Ocean. Even if it is there, how can we manage that? And how, at least in your seas, Norwegian seas and Philippine seas, are you able to extract any kind of climate signals and climate variations, their impacts on fisheries, separating it from the industrial fisheries, the impact of industrial fisheries? That's my first set of questions. And while you are thinking about it, I want to ask Faisa, thanks for that beautiful discussion on ecosystem-based management. I was excited to see how you came up with suggestions on citizen science-based observations. And I'm excited because I do work with citizen science groups, but mostly over the land. And I would like to hear at least one example on, where it has been implemented or worked out or had some kind of success, or and how, whether it was community-driven or government-driven. Yeah, I would like to hear more about that. Yeah. Thank you.
Thank you, Roxy. You mean you need examples on the implementation of ecosystem-based management?
Citizen Science Network?
Sorry?
The citizen science.
Okay. I'll give you an example. For example, we don't have whale sharks monitoring. We don't have in the whole country. And this is a very important species. So, you know, the only way we can get the sightings is through the citizens themselves, the fishermen, and the through sport fisheries, and people who are just interested to, recreational type of activities. So what they do is that when they see something, they will convey the message through the media, social media. And then we will be alerted as scientists, and then we can communicate with them, because sometimes they don't know whom to talk to. So they will just put it on the social media. Then, for example, KISR, which is a research institution, will try to contact them. And sometimes the EPA, which is the Environmental Protection, will try to contact them. The fisheries people try to contact them. And then we'll get more information from them, locations and timing, and if they have any more information, the sizes and all that. That's how we gather the information. Then we create a database based on all these sightings. Actually, all the whale sharks sightings were done by the citizens. And that's how we know the distribution, the seasons, lots of things. There are diseases, because we just don't have that part, the monitoring part. Same thing with sea turtles. These are just examples of endangered species that are crucial for us to, like, for example, the harmful algae. We cannot really monitor the whole territorial waters. When they spot some blooms, they will report it. And then we go and we check to make sure that it's a bloom, it's not like sedimentation or suspended sediments or whatever. And then we take the samples and we work with them on that. So we're really gaining a lot of information from the citizens. Did I answer the question? Thank you.
Yeah, should I follow up on your question? Well, I mean, Norway historically does not have a perfect record in terms of fishing in international waters, so I'm not claiming to be a saint here. But and I think in terms of, I call it unwanted fishing in international waters, I mean, those vessels that come into those waters will have to be registered somewhere. And I think the nations that have something to lose by having activities going on in these waters will have to pursue these vessels from their nations they're registered in. But it has been historically plenty of examples where a foreign fleet has done a lot of damage and overfished in international waters. And I think this is something that has to be brought up into international UN type level, FAO type level, let's say, measures to get a closure to that. And that also goes for the mining business, which is going to be, to a large extent, also in international waters. And we cannot have a Klondike world out there where people are rushing in to do what they want. So it is really a critical thing to get a handle on. When it comes to the Norwegian waters, I mean, in the Barents Sea, we're fortunate in a sense that it's only shared with Russia. So there's two countries. That's troublesome enough sometimes, but it's manageable. When it comes to the North Sea, there's many more nations, and with the EU, and it's always an added issue when the more nations you have to cover their own, because they will have to answer to their own stakeholders in the respective nations, right? So I'm not saying it's easy at all, but it has to be done. And fish don't see national borders; they cross whenever they want, and but they have to be managed sustainably combined by all the stakeholder countries.
Let me add to Professor Aril. In the case of the Philippines, with tuna fish stocks, again, we have agreement with we have bilateral agreement with our neighboring countries, like Indonesia. So that's where Indonesia is really a very nearby neighbor. And a lot of Filipino fishers, they really go beyond our boundaries because we have some trackers before. And also, the national government knows that. But what happens is that in order to cheat the system, so a number of our fishers, they change flags. Like they switch it to Indonesian flags once they enter the international waters. So the prevention of that has really something to do with going into very good agreement with the Indonesian Navy and the Philippine Coast Guard, as well as with the Bureau of Fisheries in the Philippines, so that those kinds of instances will be prevented. I think way back in 2007, there were instances like 200 instances of piracies in the area in Mindanao. But after the pandemic, it's like that was decreased to around 20 only, 20 instances of piracies. So we think that perhaps our governments have become more effective, both the Philippine side and then the Indonesian side. I think I can only cite those examples with regards to this, because it's really a current issue also, tuna transshipment between the border of the Philippines and Indonesia.
Yeah. Thank you very much,
Thank you.
Edison. We have one more question.
Thank you. Excellent session with complimentary talks, so very much enjoyed it. All of you touched on ecosystem services in different ways, but the message, if I'm a policymaker sitting here, the message is that it costs money to preserve the ecosystem. And my argument is there's a lot of benefits, direct and indirect benefit, and we have done, as a scientific community, a lot of work in the quantifying, monetizing those ecosystem services. Could you comment on how far the community has done in quantifying the benefits to society, to humankind, of these ecosystem services, so we can convince governments and policymakers to invest more on protecting these areas?
Actually, I'll just talk about Kuwait because I'm more familiar with that. We don't have that valuation system. We don't have it. And we're trying now because, see, for example, when they ask us at for example, the end of the year, so what's the benefits? We want dollars. Give us dollars. We don't want you to tell us, oh, we've preserved and the diversity was, we want dollars. Actually, to do that, we need some people in the economics to help us. And that's not easy, you know, because sometimes we go to them and this is really the least, I mean, they don't think it's important. They do not feel that this is something that really part of the economy and part of the food security and part of the healthy environment that all of us are sharing and benefiting from. So we don't have it so far, but we're trying now to work with techno-economics scientists to at least have an example or two. So we could show it to the policymakers that it's not always the dollars, but it's all the benefits that you get. At the end, it will, of course, feed into, you know, like, you know, if you have a healthy environment, you have also non-contaminated food, so that it caters to the health of the human being also. So it's less cost for the person to go to the clinics and get some treatment. You know, there are lots of aspects that we can show, but you know, you need to work with somebody to sort out all this. But I mean, we're working on it, but we don't have it. So, and I don't have an example to tell you from, you know, worldwide. I really don't have. So I'm sorry for.
I can add on to that from a Norwegian case again. As I showed you, relating to fisheries though, and as a settlement where people live, Norway is a long country, right? And most of the people live in the south. It's slightly warmer there. And, living up north it can be harsh, but historically they've benefited from having resources next door. Now with the situation where you have larger vessels, predominantly coming from the southern Norway, taking care of most of the fisheries, is a challenge. It's a benefit in the sense that they're very efficient and the government doesn't have to pay subsidies. But the population numbers up north are declining. And then it becomes a question of what's the value of having people living all along Norwegian coast? And it's very hard to put a figure on it. It becomes a political issue. And actually, the present government just made a major stand on that, and it's going to be highly debated, where they said, okay, we have these number of resources for cod, for example, for this species or these species, and we'll allocate this percentage to the big trawler fleets and this percentage to the coastal fleet. And they decided they want to shift from the big fleet more to the coastal fleet, which will have demographic consequences. I don't know, I haven't seen, this is not my field, but I haven't seen the economics or the summing up consequences of that. But it really becomes a highly intriguing political question. I mean, what's the value of having people living all along Norway?
Abdul Salam from SIMS Center. I would like to ask if you definitely know about 2004 tsunami happened in Asia. And after that, there was a big deal of activity for artificial reefs to recover the marine ecosystem there faster. My question is there any studies that can link the artificial reefs with the higher recovery for the ecosystem? And what was the impact on the fishery stock at the area where they put artificial reefs? Is there any study about that? Or, in numbers, we need to know how beneficiary was the, fishery stock from this artificial reefs?
Yeah, can I answer that? Yeah, in the case of the Philippines, especially in Mindanao, there was a national government, there was a deployment of these bowl-like structures, like made up of cement, and they were tested in different marine protected areas. But it was supposed to be for long-term monitoring. As of now, the Department of Environment and Natural Resources, they're still doing their monitoring, but they only saw small growth. So there were colonizations of these artificial reefs, but it's not as what they were trying to expect, like a real big growth for these ones. So for these bowl-like structures that they placed in different MPAs.
Yeah,
So
what was the
that's
impact on the
update
fishery stock?
For
Was there a positive impact from these artificial reefs? Dr. Edison, did you experience positive impact? Or?
Yeah, I can only speak for Mati, like what they were monitoring, because there's a marine protected area in that site. So for this marine, because it's already protected, so there are fish growth fish biomass growth in that area also. So, but in terms of colonization, it's not as what they were trying to expect, like completely overgrown for these bowl-like artificial reefs.
I believe in Kuwait also we have a project in artificial reefs. Can you please know
Yes.
something about it?
Yeah, we participated as KISR, Kuwait Institute scientists, with the oil company, because you can't just go and deploy things. You have to get permissions and all that. And the oil company got that permission, and they have those structures. They have specific areas where they wanted the deployment. So KISR scientists went, the divers, and they helped in that. When then we heard that it is booming. You know, there are many species there now. It's an ecosystem built now, a new ecosystem built there. Many fish species, even hamurs, the groupers, have been found there. Now, KISR came and said, could we at least document this scientifically? They said, no. This is only part of the oil company initiative. We don't need your, you know. So there is, you know, at least information that it has been successful, especially in the south. But we don't have I don't have numbers or something to show you the different species and what's the numbers, and I have no idea about that.
Yeah, I was trying to link the mass, let's say, mass production of fish at that area or ecosystem. I wanted to link it to the artificial reefs, that this cubic meter of artificial reefs mostly will produce for you that much ton of fish. This is what I was looking for. So this kind of study does not exist.
Nothing documented by scientists. Only observation divers go and they know, but we are not allowed to go take any measurements or pictures or anything, because these areas belongs now to the oil company. It's their project. So actually they don't want the interference.
Thank you, ma'am.
Engineer Khalid wants to add something.
Yes, I would like to just participate from our side, from the energy side, on the question that was raised relative to how to convince policymakers for such governances and regulations. And I think the right question is that what is the cost? The right question is what is the cost of not doing, rather than the cost of doing, because the cost of not doing, it is an existence question, I think. It is linked to the resources, availability, scarcity, as indicated by Dr. Faiza, the health relative to pollutions, the cost of losing, for example, electricity. People, they ask about the cost of quality, the cost of safety, the cost of improvement. But in fact, if you lose electricity, for example, because of quality or safety, then the whole economy can go down. Of course, there is an interactive relation between marine, because I saw that most of the presentations is around marine, and also the energy. The energy is always mostly produced at the coastal area of the seas, and so we take the feed from the sea or the water, and we send back the industrial waste into the sea or the water, impacting the whole environment. Sometimes we are impacted. If you go back to the shutdown reasoning for nuclear plants or power plants, part of it is because of the jellyfish, which is an interactive thing that indicates that there is interrelation and cross-reference between different sectors. So this is a good question. In fact, putting the policies should be justified, but the justification should cover the visionary, lifelong thinking and perspective, rather than what is the cost of doing now? Do I spend now, or I lose it afterward? So I think this is a very excellent argument between the researchers and the policymakers in order to fix the issue in a predictive, protective, mitigative approach, rather than living as a disaster. Thank you.
Thank you, Engineer Saleh. I have a question for you, if I may ask. The overarching theme in these presentations is data, data, data. We need to have data. You can have the best framework, but if your framework doesn't have data, then there's nothing. But I would like to ask, how far are we in the local industry in Saudi in developing our own innovations, tools, in the underwater environment? I know you're doing a lot in the terrestrial, but how far are we in the underwater environment?
Well, we in the GCC lab, we are now 7th year of establishment, so we don't have a lot of data when it comes to marine side. But in the solar and the wind, we have good amount of data in the electrical systems. But we have collaboration with KFUPM, capitalizing on their historical efforts for maritimes and data that they have collected. So in the future, we usually we help each other in order to work together in order to complete scopes and have the right conclusions around that is based on the data around projects and recommendations.
Yes, thank you very much.
I have a quick comment. Is it
Yeah,
okay?
yeah, go ahead. And then gentleman over here.
Okay. So this is again going back to data and quantifying the number thing. I have some examples, and one best example, and this is called economic impact assessment. Yeah. So there are countries that have done that beautifully. NOAA from the US is doing it very frequently, almost every year or every few years. They bring out economic impact assessment, and this includes economic assessment of the fisheries, the marine services, marine monitoring, and weather services all together. And similarly, I'm happy to note that our Ministry of Earth Sciences in India have brought out this on a decadal scale, the previous decade and recently also, on how the fisheries management, forecasting, weather and marine services, how we can put numbers to it, how we can quantify it. So there are these beautiful examples which can be used as references for other regions as well. Yeah, and I think it helps a lot to, when we communicate, particularly as scientists, I have always felt this difficulty in communicating the importance of marine ecosystems, even for monitoring the physical and biological oceanographic parameters and so on to the public, to the policymakers. And these numbers help tremendously. So I think any country that is interested in preserving their resources, marine resources, and also sustainably utilizing it should have these numbers, and it's possible to have these numbers. Thank you.
Can I just add a comment to that? And I think it's also based on the fact that it's much harder to observe what's underwater than what's on land. And for instance, just this simple task of counting number of fish. Somebody said it's just like counting trees, except you don't see them and they're moving. So we are faced with quite different challenges when we're working in the marine system, in the underwater, compared to the terrestrial systems. And that needs to also be conveyed in a good manner.
We are limited with time. We are allotted for 2 more questions. One here and another one.
Okay, Khalid Sheikh from National Center for Wildlife. I have just additional information related to the question from Ahmed Al-Ghamdi. I'd like to share our study in the Red Sea. We completed the study by Decade Project. We're using the best vessels in the world, which is OceanX. We're using the latest technology, equipment, tools, and labs to study the sea surface, from the sea surface until deep sea, and more than 3,000 meters. One of the reasons of the study in the National Center for Wildlife to understand the situation of the Red Sea, the coral reef, seagrass, megafauna, and the current situation of the blue ocean or organisms in the Red Sea. One of our studies is to study the eDNA from sea surface until thousands of meters on the depth. We're gonna to sharing some information of the studies in next workshop. It will held in this month, inshallah. I think it's the end of this month. Thank you.
Thank you very much. We have, do you want to respond to this feedback? No, okay. NCW is really doing great in Red Sea expeditions, Ocean X, and yeah, that would be good to replicate here in the Arabian Gulf. One more question?
Thank you very much for these interesting presentations. I have two questions, one for Professor Volford and the other is for Dr. Addison. For Dr. Volford, for Norway, I guess it's very advanced in using technology. I've been there maybe since 40 years in Trondheim. So my question is, do you have or do you use any artificial intelligence to support decision for the policymaker? Because you say that management needs policy. So policymaker needs support by prediction or by supportive data. So do you use or have a vision about using any artificial intelligence to support this one or not? For Dr. Addison, I just want to know what's the main reason for the changing pattern between the before the closing season, during the closing season, and after the closing season. There is a very, deviation between the patterns appear. So what is the main reason for that? Is it climatic related, or fishery related, or fishing related, or even contextual related? Thank you very much.
Okay. I can remember 3 examples on the top of my head, and one is ongoing efforts to optimize surveys. I mean, because they are costly, and you want as much value as possible from your survey. So having extensive modeling and use of AI to optimize that is something that's ongoing. Secondly, we're using also video-based equipment on trawls, using a system that's called deep vision, where we want to have AI-supported identification as they trawl, with the aim of opening the trawl if the species in question is not the one you were targeting, so that you could release it, and then you can close it if you're catching the species you want. So that's the aim is there to use AI for recognition online direct to be more selective in your fisheries. And the third that I can remember is the time-consuming and sometimes difficult task of aging fish from otoliths, and there's AI initiatives to optimize the reading of those structures so that it will be less laborsome and labor-consuming. So I'm sure there's more, but at least those 3.
Let me answer that. In the case of the Philippines, like what you saw about the before, during, and then after, in the Davao Gulf, this is a 3,000 square kilometer area. We have about 66,000 small-scale fishers. So actually, it's more like fishing related. The main reason why it was imposed is the small-scale fishers, they do not want competition with the commercial fishers. So they want the commercial fishers to fish outside the Gulf so that they can actually get all the catch for themselves. And because it's about food security, so the government actually agreed with them. So that's why the closed fishing season was imposed, and during that time, only the small-scale fishers are allowed to fish. So whether it's before and then during, you saw that there are some small-scale fishers that are really fishing intensely. But after that, the months are really affected by this northeast monsoon, like November, December, January, February, March. So we have strong winds and strong rains. So that also affects the fishing operation of this, because they're small vessels, less than 3 gross tons. So they could not fight the waves during this time. So there are lesser fishing effort also during this time. I hope I answered your question.
Thank you, Dr. Edison. Don't worry, we have plenty of time to ask the speakers during the break. And we just have 2 more questions that for extension. Modestar, kindly give the mic.
أيوة السلام عليكم ورحمة الله وبركاته. Thank you for your interesting information. With you, Dr. Hala Bayoumi, Associated Professor in Food Science from University of Tabuk. Actually, we are interested about edible algae that are spread in the Red Sea. We already have some studies about what is the edible algae spread in the Red Sea. We studied about 6 species from microalgae, and our result showed that there are significant differences in chemical composition, especially in protein content, fatty acids, polysaccharides that are rare in other sources. Plus minerals like calcium, iron. So we can use and utilize from this algae in different diets. Especially for vegans, vegetarians, and diets to treat the deficiency in some element. But Red Sea is large and have diversity and classified as the most region in diversity, especially in algae. So my question is about, is there any units, scientific data, help us to identify the algae, edible algae, or what is the optimum environmental conditions to cultivate these types? Thank you.
Thank you, Hala. If you're talking about macroalgae or microalgae, microalgae, you know, I can tell you that KSR did some cultures for the spirulina to see if they can use it, but it didn't go to commercial level. It's just experiments and culturing, and they succeeded in that. So this is one thing about the microalgae, if it's for food for humans. Macroalgae, we have done some studies, but the problem is the pollution. You know, I mean, the macroalgae, usually, especially in Kuwait, because we have issues of pollutants. So actually, I am not sure if this will ever happen, because, you know, people are worried about the different pollutants in the water. But they are, like, if they're in a pure, serene environment, clean, I think it's possible, of course, because Japan is doing that and other countries. But I think in Kuwait, especially, there is an issue for using this for food for humans. Feed for animals, they've also done some studies. But again, it just was an experiment. It did not reach any level of applying it as feed. So that's the status for the research in Kuwait. And we can help in the identification, because we do have, at least, you know, there probably will be 80% of the phyto, which is microalgae species in the Gulf, could be present also in the Red Sea. There might be some differences, but we can help in that, in the identification of microalgae.
We already identify and worked in spirulina, 2 types of spirulina, maxima and belatensis, and Chlorella vulgaris, Ulova lactica, many species of, but we are afraid from pollution. So we wanted to cultivate in pure environment. Thank you, Doctor.
Thank you very much. We have one last question.
Hello, myself Faima from Center for Environment and Marine Studies. My question is to Engineer Al-Mari, sir. I want to know what are the biggest challenges Saudi Arabia is facing in achieving the net zero target, And what are the developments in the green finance sector? Thank you.
Thank you very much. This is a very big question, I think. I think all of us are faced with the challenges to move on and reduce the carbon emission, contribute to the energy optimization, and conserve our resources. This is a big challenge by itself, and I think the beauty is that our country vision, mission, and all regulations are aligned towards serious and determined effort to achieve very tangible progress supported by a very structured KPI systems that is cascaded to every element of the country, every ministry, every organization to achieve and optimize and report back milestones on an annual basis. And this is monitored and registered at the highest level of the country. So this is, I think, one of the most important enabler is to set the right policies, vision, mission, and also augment it with the administrative system that pushes everybody towards maximum effort. You can see every ministry has its own arrangement. I think the Ministry of Environmental, they have already 6 centers behind this scope. The Ministry of Energy are driving this big time. In fact, the Minister of Energy, he announced that we will be the energy hub for the entire region, and there is a very ambitious KPI and target to generate more than 120 gigawatt of renewable energy, and this is very big ambition, and resources are availed and already behind this goal. So the challenge is big, we know that, and even just sustaining the same level of carbon emission is a challenge by itself. But we are putting more steps and challenging ourselves that we, by 2060, inshallah, we will achieve maximum effort towards zero emission. So I think this is a challenge by itself, but the beauty about it is that there is a lot of coordination, alignment from the top up at the right bottom of the organizations, the governmental, the regulatory, the companies, to achieve and realize the vision. So we hope, inshallah, that we will be honored to be part of such a very challenging target and very important target to our country and our globe. As we just explained, what is the cost of losing water, what is the cost of losing resources, oil, gas. This is, I think, the main drive for us to improve. If we go by the numbers that we had 10 years back, I think we will be in a very awkward situation, and we will just consume our wealth within and pollute our environment, create a lot of problems relative to resources, health, sustainability, etc. Thank you very much.
Thank you very much, Engineer Al-Amri. We would like to call Dr. Al-Hims to present a memento to Engineer Saleh Al-Amri and Dr. Faiza. Dr. Harold and Dr. Edison received a special gift last night, so.
So the rest of our guests already received their gifts yesterday in the gala dinner.
So we end our session for the...
Of course, as usual, for each track, we have to honor. Could you please? We have poster competition. So today, for this track, which is ecosystem-based management of marine resources. So the winner has a poster titled "The Anti-Fouling Efficiency of Crude Extracts Isolated from Mollusks." نجلاء العنقري, University of حفر الباطن. What is the next, please? We are going for lunch, as usual. Please, the exit's behind you. All the way, take left, and then to the main hall. And kindly, by, I think, by 1:20 maximum, we have to be here, because we're already late to start the fourth track. Thank you very much, and have a nice day.
Thank you very much.
Ladies and gentlemen, esteemed colleagues, distinguished guests, and tech enthusiasts, Assalamu alaikum, and a very good afternoon to all. I am Dr. Mani, and it is my great honor to serve as your moderator for today's session on smart technologies in environmental monitoring. In an era where our planet is facing unprecedented challenges, the role of technology has never been more pivotal. As we gather here today, we stand at the crossroads of innovation and environmental stewardship, where cutting-edge smart technologies are not just tools, but beacons of hope in our collective quest to safeguard our natural world. From the depths of our oceans to the expanse of our skies, smart technologies are unlocking mysteries and providing insights that were once beyond our reach. We are witnessing an era where real-time data, artificial intelligence, and Internet of Things converge to create a symphony of sustainable practices, empowering us to act with precision and foresight. As we embark on this journey today, let us open our minds to the possibilities that lie ahead. We are about to explore how these technological marvels are not just monitoring, but actively protecting our environment, turning data into action and challenges into opportunities. It is with great honor that I introduce our first keynote speaker for this session, Engineer Adnan Aliliani, a distinguished figure in the field of environmental technology. Engineer Adnan's remarkable career, extending over 16 years, has seen him make impactful contributions across various sectors, including oil and gas, academia, and notably environmental sustainability, establishing him as a leader and innovator in the field. He is currently serving two positions, one as the General Director of Environmental Technology and CEO Advisor, and another as the General Director of Permitting and Licensing, both for the National Center for Environmental Compliance. Engineer Adnan's academic achievements are equally impressive, with a master's degree in mechanical engineering, focused on environmental clean energy, a bachelor's in mechanical engineering, both from US, and he also has a foundation associate degree in nanotechnology and engineering from New Zealand. These qualifications, combined with his practical experience, underscore his innovative approach to environmental technology. A polyglot, fluent in English, Arabic, French, Spanish, and Italian, Engineer Adnan's linguistic abilities reflect his global outlook. As the founder of MacBlash, a non-profit organization specializing in autonomous mobility and artificial intelligence, he shows a steadfast commitment to leveraging technology for environmental goals. Honored with 19 international certificates and numerous awards, Engineer Adnan's vision and dedication to sustainability are truly inspiring. Please join me in welcoming Engineer Adnan, a visionary leader in the environmental technology, to deliver his talk. Engineer Adnan, the dais is yours.
Assalamu alaikum wa rahmatullahi wa barakatuh. And welcome to the fourth session entitled Smart Technology and Environmental Monitoring, as you can read on the screen. Our presentation today is going to be more in-depth about the technologies and how we use this for monitoring the environment and all the impacts possible. So before we talk about this topic, let's just go a little bit over the mandates of NCEC, the National Center for Environmental Compliance, what we do and what we aim for. So the National Center for Environmental Compliance has a mandate to protect environment and preserve its resources by providing high quality services that contribute to contribute to raising the level of compliance with environmental regulations and standards. Also, we aim to enhance the environmental sustainability, which is the main theme of this conference. Contribute to prosperity of development sectors, including institutional and research centers. For example, this university, University of King Fahd for Petroleum and Minerals. We also work with all parties in all workshops, conferences, forums, for the sake of showing or making sure the other entities and parties know well what the environment or environmental regulations and standards and criteria requirements are, and therefore they are more compliant, which is the main goal we have. A little description about the department I work for, which is Environmental Technology Department. It works under the Directorate of the Executive Department of Licensing and Compliance. We also offer services that contribute to the transformation and adoption of environmental technologies. We aim to continuously foster innovation and promote public participation and engagement, such as universities and parties within our scope of work. Through advancing the use of environmental technologies, we encourage environmental compliance and reducing pollution. We as a department aim not only for the department itself, we aim for the big vision, which is as you all know, the 2030 vision, and that goes through the center and the national environmental strategy, and finally to the 2030. What we do for the 2030 vision, we enhance and we do the enhancement of manufacturing of local environmental technologies. We collect or we create a database of local environmental verified technologies manufacturer, enable KSA in manufacturing rather than importing, as we all talk about the local industry. Local manufacturing of environmental technologies, which ultimately increase foreign investment to come in the country and invest. For the national environmental strategy, what we do there is raising the environmental awareness in the kingdom, development of a reliable network of environmental NGOs, development and rollout of environmental R&D strategy, adopting state-of-the-art technologies for the environmental protection. And for the center, we align the environmental field for the 2030 vision, as we mentioned earlier, support the and motivate environmental technologies, enhancing environmental development, raising environmental awareness in the kingdom. In the department itself, what we do is various of work, such as evaluating, verification, validation, and later on we will qualify environmental technologies as they are or not eco-friendly technologies. So for the evaluation, we provide unbiased evaluation of environmental technologies based on international standards so far, and also the ISO. verification, we do collaboration with third parties, entities, accurately verify environmental technologies. And through the knowledge that we have in the team, we have a lot of experts and specialists in environmental technologies. We establish a data portal and an inventory of all environmental technologies in the kingdom. For the engagements such as this one, as we are here for the purpose of engagement, host regular workshops rather than just going to other forums and conferences. We establish our workshops and conferences, forums, as we are going to have a forum in a month from now entitled environmental compliance, and I encourage all of you to go to our website and register to that forum. It's going to be on 26th, 27th, if I'm not mistaken. Everything is written down in the website. All of this is actually what we call token in the air. To be more specific, we have to have a goal, and that goal is actually the Saudi Green Initiatives. As you all know, there are 60 initiatives undergoes this big initiative, and a lot of entities join together to make this happen. And what we do is to make sure we are aligned with this. And as you know, Saudi Arabia has pledged to achieve net zero carbon emissions by 2060, and we have to be committed to this target, and we do anything possible to make it happen. The Saudi Green Initiative is a national master plan that unites environmental protection, clean energy development, and sustainability program. It is important to understand the role of smart technologies in environmental monitoring to achieve our goals. Now, I talk you from what we do until the future goal. Now, let's talk about the presentation itself, which is the smart technology for the environmental monitoring. And before we jump to that, we need to understand what smart technologies are and what is environmental monitoring. So smart technologies refers to devices or systems embedded with advanced functionality like connectivity, sensors, data processing capabilities. It plays a significant role in enhancing environmental monitoring for compliance by providing accurate and real-time data, and that's what we look for. This will make our life easier, will make us rely on reliable and robust data, facilitating proactive compliance management. Instead of being reactive to the changes, we need to be proactive, see what's going to happen. Rapid response to a deviation. So if there is anything that goes off the track, we need to know how to respond to that. Help applying sustainable practices, and that goes through local experts and also international experts. Environmental monitoring and its significance. This is a very important topic. Environmental monitoring involves systematic observation and measurement of environmental parameters to ensure adherence to regulatory standard and laws. It ensures all activities comply with environmental regulations, preventing or mitigating potential harm to ecosystems, human health as a final result, overall environment. let's talk about the difference between the smart technology and the traditional way or traditional method of dealing with the stuff, or let's call it old school and new school. So previously, traditional environmental monitoring methods often involve a manual data collection, which can be time-consuming, expensive, and labor-intensive. However, with the advent of technology, monitoring systems have become more efficient, accurate, and accessible. And I would add to that, more robust and reliable. For the deep talk about technology, I would like to invite one of my colleagues, Engineer Mishari, as he knows a deep technical information about technology, and he actually the one who prepared this paper for you. So I would like to give a round of applause to Engineer Mishari. And I don't know if you know.
Moving on, ladies and gentlemen, it's my pleasure to introduce our next speaker, Senior Environmental Technology Specialist and accomplished chemical engineer, Engineer Mushari Al-Zahrani. Engineer Mushari brings over 5 years of experience in the oil and gas industry, showcasing deep knowledge in various industrial chemical processes and technologies. Engineer Mushari has a rich background in environmental technology, having served as a Senior Environmental Technology Specialist in NCEC since August 2023. Prior to this, he was a technical engineer 1 at Nalco Water, an Ecolab company where he managed major industrial accounts in the MEA region, focusing on performance optimization and system efficiency. His expertise extends to sales engineering with a notable tenure at Reda Oilfield, where he managed key EPC companies and projects. Furthermore, Engineer Mushari has experience in business development, honing his skills at Eastern and Industrial Electrical. In the early stages of his career, Engineer Mushari contributed significantly as a process operator at SABIC and as an operator at Saudi Aramco Total Refining and Petrochemical Company, emphasizing on his hands-on experience in the field. Engineer Mushari is a proud alumnus of San Jose State University, where he earned his bachelor's degree in chemical engineering. Please join me in welcoming Engineer Mushari, a distinguished professional with expertise and experiences as set to enrich our understanding of environmental technology. Engineer Mushari, the floor is yours.
Assalamu alaikum. Jazakum Allah bil khair. So thank you, Mr. Adnan, for this introduction. I really appreciate it. So now we're going to talk about some technicalities. I'm going to talk about the types of smart technologies in environmental monitoring. Some of the types are, the main, I would say, types of it is smart network, remote sensing, and data analytics. And move on to talk deep about it. So smart network. So it's the use of IoT sensor for real-time data collection. The definition of IoT sensors is the integration of interconnected sensors and devices related to environment to collect, transmit, and analyze data. IoT devices equipped with sensors to monitor in real time air quality, water quality, soil quality, and more, I would say, technical parts of an environment. So these devices communicate with each other, often through internet, enabling data collection and analysis. So this is, I would say, how it works. We have sensors. Let's say this is an example. This is an air temperature and power meters. It sends data to the IoT gateway, where it goes to the router, which sends it to IoT platform. It's the database server. Then it will send it to our dashboard or remote access dashboard, where we visualize and have alerts and reports about it. This is how it displays. It's like a generic information, the main information I would say about it. Move on to the remote sensing, which is satellites and drones for environmental monitoring. So the definition of environmental satellite is a device that detects and observes different characteristics and features of the Earth's atmosphere, land, surface, and ocean. For environmental drone, it's defined as unmanned aerial vehicle monitoring that safely track potentially deadly disaster areas and collect important environmental data in even the harshest condition. It works together to collaborate, to contribute together to invaluable data for scientific research, conservation efforts, of course, and it contributes to working together to in disaster management. For satellites, are constantly gathering data to monitor and understand our dynamic planet. It gives us an environmental cycle. It gives us, like I would say, many years of I would say, impact of, for example, carbon monoxide, and greenhouse gases in general. It's ideal for monitoring climate change because they monitor the concentration of greenhouse gases in the atmosphere, such as I said, aerosol, water vapor, carbon monoxide, carbon dioxide, and methane. So why we are using drones? Because of, I would say, mainly three things. The first thing is it gives us a high resolution imaging. And also it is very flexible. And we can customize it to whatever we want. For example, in the space that we need, for example, to take a carbon dioxide data. So we can input or implant the sensors in that drone to take the specification that we need. The application of it can measure water, air, and soil parameters. For air quality, the smart air quality sensors can measure pollutants such as PM2.5, PM10, nitrogen dioxide, and ozone. It gives us a real-time monitoring of air quality. It helps us in identifying pollution hotspots and taking corrective measures. For water, smart sensor can monitor parameters like pH, temperature, dissolved oxygen, and the most important thing that we are focused on is the turbidity in water bodies. The real-time monitoring of water helps us in identifying contamination sources and ensuring safe drinking water. The smart technologies enables efficient water resources management and early detection of water pollution incidents. To the third part of smart technologies is the data analytics, is the role in processing the big data. So what's the challenge that we have? The challenge that we have is the sheer volume of data that generated by sensors, networks, and remote sensing technologies can be overwhelming. We have many data. We cannot, by individual, solve that or find patterns in that data without the using of I would say, the AI or machine learning or the technologies overall. So the solution is data analytics process and analyzes this big data swiftly, identifying patterns, trends, and outliers that may go unnoticed through the traditional method. So we are going to talk about two things about the data analytics. is the pattern recognition and anomaly detection. And this is a very important topic. So in pattern recognition, we are using AI. So AI algorithm excel and recognizing interact patterns in the environmental data. This aids in understanding the cycles of environments. Anomaly detection, with the help of AI through machine learning algorithms, it will detect anomalies in environmental matters environmental patterns, alerting of potential environmental threats. Here, I'm using our center in CEC as a case study. So what we do at National Center for Environmental Compliance. At NCNC, we are using smart technologies like drones, satellites, and smart remote sensor to monitor the environment. We have more than 240 air quality monitoring stations. We have 147 noise pollution monitors. We have 100 light pollution monitors in 20 centers nationwide. This is a map showing the station or Saudi monitor station map in Saudi Arabia. On the right side, we have the Riyadh monitor station map. And this is mainly for air quality. Of course, our efforts will not be enough. So we do collaboration and cooperation with entities like Saudi Aramco, KAUST, RC, and to carry out air quality monitoring operation in the kingdom. With that collaboration, we have more than 400 air quality monitoring stations. 240, as I said before, 240 of them are NCACs. This is the process of monitoring at National Center for Environmental Compliance. We're starting from the ambient air quality monitoring station. It goes to our servers to process and observe data. We have also high-speed computer, and also high-resolution softwares. How we work, how we do the validation and verification of this data, we have our own methodology. It relies on international practices in data management and analyze using more modern technologies and softwares. It also works on review and auditing operation to ensure quality. This is the station, the real-time monitoring station in Jeddah. We have many specialists working there to give us reports and dealing with alarms, and also validates, as I said before, the data that we collect. For the future, NCEC is aiming to use advanced technologies to monitor emission at the source throughout the country. What we input or implant is ambient air quality station, air quality station. It's the ambient air. The future will be from the source to give us, I would say, a real-time data from the pollution source. Thank you so much. And before I end up my presentation, I would like to thank GiKS organizers, and especially Dr. Luail Hems for his initiative. And also, I would like to thank our leaders, the NCEC leaders, starting from Engineer Ali Al-Ghamdi up to my mentor and my idol, Director Adnan Al-Ayani. Thank you so much.
For the thought-provoking presentation by both engineers, Dr. Adnan and Dr. Mashari. So moving on, ladies and gentlemen, our next keynote speaker is Dr. Roxy Matthew Cole. Dr. Roxy Matthew Cole is a distinguished climate scientist at the Indian Institute of Tropical Meteorology, renowned for his groundbreaking contributions to climate change variability, Earth system modeling, ocean atmospheric dynamics and interaction, tropicals interseasonal variability, Indian Ocean and Asia monsoon, biophysical interactions in the marine ecosystem, and climate change impact on health. His dedication has resulted in over 106 publications and garnered over 5,000 citations, cementing his position as a leading authority in the field. He completed his PhD in Ocean and Atmospheric Dynamics from Hokkaido University in Japan. Dr. Roxy has been instrumental in advancing our understanding and forecasting of the Indo-Pacific climate, significantly contributing to the region's food, water, and economic security. His leadership in revamping the Indian Ocean Observation System and pioneering the first South Asian climate model has been pivotal in enhancing the science, monitoring, and forecasting. His current research focuses on the effects of climate change on monsoons, cyclones, heat waves on the marine ecosystem. As a lead author of the IPCC reports and the former chair of the Indian Ocean Region Panel, Dr. Roxy's contribution to climate science are globally recognized. He is known for his active engagement with citizen science networks, local authorities, and media to disseminate scientific knowledge to the broader community. In recognition for his outstanding contributions to Earth and space sciences, Dr. Roxy was named a Fellow of the American Geophysical Union and received the prestigious AGU Devendra Lal Medal in 2022. Stanford University ranks him among the top 2% scientists worldwide. His accolades also include several fellowships, and in 2016, the Indian Meteorological Society honored him with the Young Scientist Award for his significant research on monsoon changes. So without further ado, I would like to welcome Dr. Roxy to deliver his talk.
Thanks a lot, Dr. Mani. Hello, folks. I'm quite excited to be here. This is my first time in Saudi Arabia, and I'm amazed by the positive vibe that is present here. And before getting into my own story that I'm going to present here, I would like to take a moment and talk about your story. This is fine? Yeah. So I would like to congratulate KFUPM and GiKS, or GiKS, working towards looking forward to a green future. I'm also quite excited to see a lot of youngsters here, particularly women. You are the future. Bravo. Asante. Asante is the bravo in Arabic, I guess. Asante. Asante. Perfect, yeah. There you go. So coming to my story, even my story here, as you see in the title, related to Indian Ocean warming and all, actually connects to your story of Saudi Arabia as well. We'll see how, some ocean basin and changes happening somewhere else is impacting the heat and weather variability over Saudi Arabia, and why we all need to work together to understand it, to forecast it, and build resilience. Well, of course, we know Saudi Arabia has faced harsh challenges, particularly based on the geographical region it is, where it is, the heat. But what if these extreme heat and other challenges, particularly climatic challenges that we are seeing, are pushed into further extremes? Like, I will quote Ben from yesterday. He was saying in his panel discussion that Saudi is going to get hotter and hotter. But there is something that I want to say. Thank you. Yeah. If I didn't get this, I would keep on talking and talking without moving through the slides, right? Yeah. So there is something I want to say. Some of these events could be predicted. For example, in the same panel discussion came out the discussion on ENSO, El Nino. So we know this is an El Nino year, 2023, 2024, and the temperatures are going to be up, right? Which means there is some predictability. Even while climate change is happening, the temperatures are going off chart. We know, okay, this year the temperatures are going up. Next year, if it is a La Nina, the temperature might go down. So we need to understand these links in the climatic system, in the Earth system. If you want to predict, if you want to build the smart future, the green future, the NEOM, attain the sustainable development goals that the mayor was talking about yesterday. All this will require building that resilience towards the climate changes of the future, not just for the past. Yeah. So if instead of 45 degrees Celsius, you are going to face 50 degrees Celsius, right? But we need to know that information if you want to build that resilience, right? How can we extract that resilience? So folks, I'm Roxy Kaul from the Indian Institute of Tropical Meteorology in Pune, under the Ministry of Earth Sciences in India. And I have been working for quite long on climatic variability and change over the larger Asia-Pacific region, yeah? On cyclones and extreme weather events, heat waves, and so on, and I worked with the IPCC as well. And some of these results are arising from these studies and research. Now, this is a background picture that I'm showing here. This study is coming from Saudi Arabia itself, and it shows Saudi over there. Yeah, anyway. Doesn't matter, you can read that, yeah? So this shows how well it's connected to ocean temperatures across the globe. This is a backdrop picture that, just for information that I'm showing here, yeah? And the weather conditions over any region are largely modulated, regulated by oceanic conditions, yeah? For example, the ocean temperatures, they drive the atmospheric circulation and change the global weather pattern. And for many regions, El Nino or El Nino Southern Oscillation, yeah, which happens somewhere in the Central and East Pacific, are a driving force. But these numbers that I have highlighted here show a different picture. It's not just the Central and East Pacific, it's actually the Indo-Pacific region, or what we call the warm pole in the Indo-Pacific. IPWP stands for the Indo-Pacific warm pole region, where the oceanic temperatures are permanently about 28 degrees Celsius. It supports strong convection, supports all the, it's a heat engine of the globe, oceanic heat engine. It supports the weather patterns that you see across the globe, particularly in the tropics, and influences the extratropics as well. So you can see a correlation close to 0.78, which is much large compared to the correlation that you get for the Nino region, which is the Central East Pacific here. In essence, it means that Indo-Pacific warm pole region that is highlighted there, the oceanic conditions there can affect the weather conditions in Saudi Arabia, yeah? Now, in this Indo-Pacific warm pole, the Indian Ocean, now this is one of my favorite subjects, the Indian Ocean is warming at a very rapid pace. And this has close links to many weather patterns and impacts that we see in Saudi Arabia as well. Now compare the temperatures, the values that you see here with global average temperatures, yeah? Global mean temperatures reached around 1.1, 1.2 degrees Celsius recently. And that is compared to pre-industrial period, starting from 1870s, 1900s. Now, these are the sea surface temperature trends, SST trends, over the Indian Ocean from 1950 to recent period. You can see values up to 1.2, 1.3 degrees Celsius. And this block that you see, the text that you see is from IPCC chapter 9, I guess, on the oceans. It says since the 1950s, the fastest surface warming has occurred in the Indian Ocean, among other coastal regions, compared to other coastal regions. Now, it doesn't stop there. That is about 1.2 degrees Celsius, but if you plot the future projections as well, that you see over here with the different shared socio-economic pathways or the future pathways based on the emission scenarios, the past change of 1.2 degrees is like flat, yeah, compared to the future that we are going to see. So if you got 1.2 degrees Celsius now, it's going to be, that's per century, it's going to be 3.8 per century in the near future, yeah, particularly with high emission scenarios. Does it impact Saudi Arabia? Will it impact in the future? Has it impacted in the past? We'll see. One example is this. So here you see, on the leftmost, you can see how a warm pole is depicted there. Ocean temperatures go, all those orange, pink, orange, red colors are where the temperatures, ocean temperatures are above 28 degrees Celsius. Yeah, that's a warm pole. Now we see that since 1900s, the warm pole is expanding even to the western part, Western Indian Ocean, Arabian Sea region. So the warm pole temperatures are gone up, close the gap between the earlier warm pole temperatures going up to 28 degrees Celsius and so on. You can see the orange line going up. Yeah? And this results in conditions like the snapshot I'm showing over there, the last satellite picture, top right. That's a snapshot of just one day in December in 2019. You can count 1, 2, 3, 4, 5. 5 tropical storms just in the western parts of the Indian Ocean. One close to Saudi Arabia. And this has definitely resulted in heavy rains, probably some floods also over that region. Yeah? And that's a tropical cyclone. I forgot the name of the tropical cyclone. This happened in 2019. And this happened when warm Indian Ocean temperatures coincided with some weather patterns called Madden-Julian oscillation and so on. But what did it result into? You can see the map of locusts here, which is quite an interesting story. There are some papers referring to that as well, Indian Ocean warming, how it triggered off locust swarms and all, because all this warming in a previously cooler ocean temperatures resulted in more convection, more clouds forming, more rainfall, especially in the deserted regions of East Africa. It triggered vegetation, sudden vegetation. Certainly, it was helping the locusts to breed and form and form swarms. Yeah? And this spread across the African region, then moving on with the moist winds and the storms to Arabian region. So I saw news reports that agriculture and crops and conditions in Saudi Arabia was also affected by these locust swarms during this 2019-20 period. Yeah? And not only that, it crossed over to Iran, to Afghanistan, to Pakistan, to India as well, and to even close to where I live, to almost to South India. And the wonder was, we saw the locusts in the Himalayas. One of my media friends captured a video of locusts in the Himalayas. Yeah? This is how far-reaching some changes in somewhere in the Indian Ocean, can impact regions across. Now, the story I want to tell is slightly different, and how we can understand it as well. And for that, from ocean warming, I am getting into an extreme form of ocean warming, what we call the marine heat waves. This is a term which was coined just 10 years ago. These are like heat waves in the ocean, just like you have heat waves. You have heat waves in the ocean as well. Yeah? If I explain this figure, you can see the temperatures on the left axis going from 28 to 32 degrees Celsius, right? That's the ocean temperatures in the Bay of Bengal, I would say. For example, you would see the bottom right maps. One is the sea surface temperatures during the average conditions, and the right is when you have a marine heat wave. So on the rightmost, you have the color scale there, going from 19 to 33 degrees Celsius. You can see during a marine heat wave how spread it is across the Arabian Sea and the Bay of Bengal. Temperatures are going, instead of 28, 27 degrees Celsius, they are going up to 32, 33 degrees Celsius. Yeah? So if you look at the chart, the blue line is what the average temperature should be. This is again in 2020, April, May, just before the monsoon season, yeah? And in the Bay of Bengal. So average temperatures should go between 28, 29 degrees Celsius. But you can see that black line, if you follow that black line, it goes up to close to 32 degrees Celsius. That's like a 3 degrees Celsius marine heat wave, and almost lasting for a month. Yeah. Now, there is technical definition and all, I am not getting into it, that whatever goes above that green line, which is the 90th percentile, is where we identify it as a marine heat wave, and if it lasts for 5 days. Now, what happened with this particular marine heat wave? You can see an icon added to that chart, which you saw earlier. So almost 1 month after the marine heat wave, you can see a cyclone formed in the Bay of Bengal. So very warm ocean temperatures, they're the consistent supply of heat and moisture for cyclones to develop and intensify. Yeah? So one extremely severe cyclone popped up there. That was in the Bay of Bengal. Yeah? Now again, what does that has to do with Saudi Arabia? We will see. So keep focused. Yeah? So this, after the cyclone, once the cyclone is there are strong winds, it cools the ocean temperatures. You can see a dip, but the temperatures go back again, almost close to the marine heat wave. Yeah. So these kind of marine heat waves are happening again and again. And we see that about 80% of the cyclones in the North Indian Ocean, particularly in the Bay of Bengal, are preceded by marine heat waves like this, 80%. Yeah? This from the data of the last 40 plus years. Now, there is when we have these cyclones intensified by marine heat waves, yeah, there's a huge updraft over the ocean. So think you have the Arabian Sea, the Bay of Bengal, huge updraft which goes up to the troposphere. The moist air is rising. And this rising, so the blue is for the earlier period. And the red, the orange, is for the recent period. We see that the cyclone updraft is much more stronger in the recent period. So I'll show it pictorially, okay? So this is the Bay of Bengal, averaged cyclone updraft, okay? So how the moisture, winds, and everything is rising up. So this updraft has to end somewhere. There is an outflow of this updraft. That is what you see here. So how does it happen? So there is an outflow in the upper atmosphere, and then there is a subsidence, okay? So if you have a moist, warm moisture updraft somewhere, it has to compensate with a dry air subsidence, yeah? And when air subsides, it heats up. And that's what I show here. Now, this is with the map of Saudi Arabia and the Indo-Pak region, the entire region. Now, this is where it all connects. So the figure below that I showed earlier is connected with the figure above. You can see the blues over the Bay of Bengal shows the region where you have the strong updraft. So you have the marine heat wave in the Bay of Bengal, then a cyclone updraft, yeah? But where does the subsidence, dry air subsidence happens? over the Indo-Pak region and Saudi Arabia. Very clear, those red colors show where the dry air subsidence happens. So when this happens, the air compression due to the pressure and so on heats up. Yeah? So it heats up the surface, and also it prevents the formation of clouds. So there is more solar light coming in, solar energy coming in and hitting the surface over both the Indo-Pak region and Saudi Arabian region. So temperatures go up, tremendously up. So this is an example from, I think, Saudi online website of the weather charts that I saw, which shows that subsidence due to a heat dome happening over Saudi Arabia. And this was following a cyclone. This happened somewhere in, last year, June 2023. Temperatures going up to 50 degrees Celsius. Now, these kind of temperatures are exaggerated because of this kind of subsidence happening during cyclones as well. It doesn't mean that during other times you won't have a heat wave. But this is one kind of predictability that I'm showing. Temperatures, these are the anomalies that you see, up to 3 degrees Celsius or above over the Indo-Pak and Saudi Arabian region due to that subsidence over the same region. So these kind of heat waves or extreme heat can happen over this region due to changes somewhere, which means that we need to monitor why this is happening. If we monitor, we can put that data into models, weather models, climate models. We call them initial conditions. And this is required to forecast heat over this region, over the Arabic region as well. Yeah? So if we forecast, and if we know how it is going to change in the future as well, we can build that resilience. Our infrastructure can be made according to these changes. Now, again, I'm going back to the same marine heat wave thing over here. So on top right, you saw the same, the picture that we saw earlier. So the same, when measured by an oceanic mooring. So this is a moored buoy data. You can see the temperatures are actually going to 33, 34 degrees Celsius. Now, this is in the open sea. I know in the Red Sea and probably in the Arabian Gulf also you might get high temperatures. But in the open sea, we have never seen oceanic temperatures reaching 33, 34 degrees Celsius. And that's what we are seeing with these marine heat waves. And it goes down with a cyclone. But there are only scantily few monitoring systems and observations, sustained observations in the Indian Ocean. And we need sustained observations for sustained weather services, weather forecasting, for sustained climate services. Otherwise, our forecasts, otherwise our weather services and climate services will go wrong. And that is where I reach onto the roadmap of Indian Ocean observations. Yeah. This is a picture prepared by Jamsek from Japan for a review of the Indian Ocean observing system, sustained observing system in the Indian Ocean for the entire region, for the Arabian Peninsula, for Asia, Africa, Australia, and probably beyond that as well. So this has the potential to provide services, weather and climate services and marine services as well that we were talking about in the early section for agriculture, farming, water resource management, fisheries, marine transportation, tourism, weather, climate, ocean forecasting models, and so on. There is a huge report with about 25 chapters, which I was a co-editor of. This is available online. And a lot of efforts went into this. This was a 3 to 4 year effort, putting all together what kind of observations we need in the Indian Ocean. And some of this can be taken up by the Gulf countries as well, including Saudi Arabia. I'm not getting into the numbers, but this is a roadmap or the history of how we came so far. In the 1990s, the Pacific was well observed, the Tower Triton Array and so on, so that we know about El Nino and so on right now. But at that time, the Indian Ocean was scantily observed. From that, we reached to the 2000 vision, the original design and current status. But this was built to just understand the ocean dynamics, the monsoon, and so on. But since then, in the last 2 decades, the new challenges came. Climate change and extreme weather events came as a new challenge. So we need to redesign this observing system. And that's the vision we call the INDOS 2, Indian Ocean Observing System 2. And now, mind you, these are sustained observing systems where the data is shared in the public domain and can be accessed by anywhere and is given to the weather and climate forecasters, services, agencies across the globe. And we have different observing systems like Argo, Rama, Omni from the Indian Basin, XBT, tide gauges, surface drifters, and voluntary ghost ships, and so on. But there are new technologies as well. Now, one of the core recommendations, some of the core recommendations was that improve the chemical, biological, and ecosystem measurements alongside the physical parameters, because most of the time physical parameters are measured more. Expansion into the Western Indian Ocean. You can see that even in the vision for 2020-2030, the Western Indian Ocean is scanty compared to other regions due to multiple reasons. And one of the key recommendation is the expansion into key coastal regions. Coastal and marginal seas needs to be better observed for multiple reasons, for closing the heat budget and also the energy budget. Yeah? Without understanding this, we cannot understand the climatic conditions on how this region is changing. But in between, so we made all this vision before 2019, and suddenly COVID struck. And look at what it has done to this observing system that are important for weather forecasts here as well. So in December 2019, about 90% of this, one of the observing system, that is called the Rama. Rama means Research African, Asian, Australian Monsoon Array for the Indian Ocean, yeah? So it was 90% functional. 3 years ahead after COVID, December 2022, only 2% functional. Which means it is affecting weather forecasts here, weather forecasts in India, South Asia, across the globe. Now, 98% of the mooring buoys are not functional or lost, yeah? And this is because many of these open ocean moorings needs to be frequently serviced and installed as well. Now, this is where countries can work together. Regional partnerships are quite important. And one example of that is where the Indian Ministry of Earth Sciences opened up its Omni mooring data. So there are moorings from the Ministry of Earth Sciences, particularly institutions like INCOIS and NAOT in India. They have moorings which are colored in blue and orange over this map. So this framework was brought together with the Rama moorings, which are mostly managed by NOAA from the US. About 50% of the moorings in the, can I have some water? Sorry. I get excited while I talk and end up coughing. Yeah. So, these kind of regional partnerships can enhance the data coverage across these ocean basins. And it's not just sustained observing systems. There are regions where you can't observe, particularly exclusive economic zones or narrow straits. That's where advanced technologies like this This is called a sail drone. Some of you might have heard about it. This is wonderfully deployed by, despite being a private enterprise, this is wonderfully deployed by the US NOAA. In fact, they did a cross-Atlantic observation using the sail drone. So these are uncrewed surface vehicles combining wind-powered propulsion technology with solar-powered met and oceanic sensors. You can see that in this figure here. You have anemometer for the wind, wave height, atmospheric conditions are measured, oceanic conditions are measured, there's a CTD, there's pH, ocean biogeochemistry, SST, air temperature, optical camera, dissolved oxygen. So all these sensors, and you don't need a ship to go somewhere and measure these parameters. But this is expensive. One day, it's about $2,500, just one day use. But compared to the ship time and the office's time, which can be up to $30,000 per day, this is a much beneficial, potential way of measuring the oceans. And it can go anywhere. It enables a mission duration of up to 12 months without the need to return to land for maintenance or refueling. It can travel at an average speed of 2 to 6 knots under wind power and can reach most oceanic locations in a few days' time. But we need something where advanced technologies are married with low-cost technologies as well. Because in this region, not all countries can spend huge amount on measuring the ocean. And we were talking about this. And this could be low-cost technologies which can even be used by citizen science networks that Faisal was talking about. This is an example, plus PA camera for underwater physical and BGC observations. This is another wonderful example. These are low-cost drifters measuring currents. Just a buoyant tube with radially clothes connected with the foam poles, which measures the currents over 1 meter over the ocean and can do that for almost a year's time. And it's less than $100. So many of these African nations, or any country, or citizen science networks in these regions can use this kind of low-cost technologies. And in regard to that, I would like to advertise this from my colleague, Greg Covey from the University of Edinburgh, what we call the CoLab. So I was part of the Indian Ocean panel, and one of my colleagues introduced this lab in a box. So you can Google about that. So all the instruments that we saw in the sail drone, with the sail drone, yeah, all these sensors, including CTD and ADCP, that's the current profile measurement, can be put in, are made in 3D printed, some of them are 3D printed, are assembled in such a way that you can carry in a few crates of 23 kilos or so. So you can carry with you in a flight and go somewhere and deploy this. This low cost, modular, open access, you can just Google and see. So we need a marriage of these kind of low-cost technologies along with the high-cost technologies if you want to measure this global Indian Ocean region. And this was introduced along with the capacity training in the East African region, that's the Western Indian Ocean region. We had these capacity building programs as well. We can see hands-on training was there, both with the software and deployment of some of the underwater vehicles. So we need this kind of regional partnerships if you want to go forward with observing, monitoring these conditions and their impacts on the Indian Ocean. And that is what I'm highlighting here. Sustained Indian Ocean observations require sustained regional partnerships. Thank you. These are my colleagues from Indian Ocean Network, from my lab and IPCC team and the Indus Forum. Thank you very much. It has been a pleasure to talk to you.
Thank you, Dr. Roxy, for sharing your wisdom and insisting on the insights. Especially, special thanks for introducing us to PLASPI and Collab. Ladies and gentlemen, prepare to dive into the fascinating world of oceanography with our next speaker, Professor Bert Jones, a distinguished academic with over 4 decades of dedication. Professor Jones currently leads the Saudi Aramco KFUPM Marine Environmental Research Center, so spearheading crucial research efforts at KFUPM with over 230 publications and around 6,400 citations. Speaks volumes about Professor Bert's influential research, establishing him as a key figure in ocean optics and biological oceanography. His journey began at Duke University, where he earned his PhD in biological oceanography. Throughout his esteemed career, Professor Jones has traversed the globe, enriching the field through his expertise in coastal process, water quality, and the complex interaction between biology and physics in the marine environments. Joining KFUPM in 2012 marked a new chapter in his dedication to oceanographic advancement. Here, he spearheads biophysical projects, diving deep into areas like biooptical oceanography, physical biological interactions, and coastal urban issues. His research, particularly focused on the Red Sea, sheds light on the dynamics of these interactions in marginal seas around the world. Professor Jones' expertise extends beyond theoretical understanding. He is a master of observation, employing ocean observations, remote sensing, numerical modeling to unlock the secrets of the deep. His passion for technology drives his development of instrument systems and ocean observing networks, further fueling our collective knowledge. At KFUPM, Professor Jones continues to unveil the Red Sea's biogeochemical processes, unravel the mysteries of coral reef systems, and champion sustainable usage management. Please join me in welcoming Professor Bert Jones, a true ocean explorer. Professor Jones.
Dr. Manny, and thank you to this KFUPM and the Center for Environmental and Marine Studies for organizing this great meeting. The talks have been really inspirational. Ben Horton set the stage for the urgency of response to climate. What Roxy has just talked about emphasizes key things that we need to be aware of, that we need to take into action for what we're doing in the Red Sea and the Arabian Gulf. And so they sort of set the stage for what I'm preparing for. And the earlier talk from NCEC sets the stage for the automation that we're looking to introduce. So I come from as Dr. Manny said, I'm an oceanographer. I come from a long time participating in ocean observations. And interestingly, when we look at Vision 2030, it had this statement in here. By preserving our environment and natural resources, we fulfill our Islamic, human, and moral duties. Preservation is also our responsibility for future generations and essential to the quality of our daily lives. And I think we saw the emphasis on preserving things for future generations with the impact of climate change that we saw yesterday. I've just a note talking about climate change. I was updating our records for the Arabian Sea from satellite data. Sea surface temperatures in the last 2 years have been more than 2 degrees above normal during the summer period. What we're seeing are stronger extremes, though. The winter times have been more than 1.5 degrees below normal. So we're seeing significant anomalies in both directions associated with this. So there's an emphasis in the kingdom in Vision 2030 on preserving our environment and our natural resources. How are we going to do this? The kingdom is banking a lot on its natural resources. Some of our discussions earlier talked about environmental economics. It would be really useful to have a representative who specializes in environmental economics at one of these conferences so that we could understand what the economic value of these systems actually is. Saudi is banking on these resources for its future, for part of its, as we move away from the oil economy. This is from Amala, and so what we're looking for is tourism opportunities that take advantage of this environment, that we can, So we have this people who are actually able to engage with the environment. So preserving our environment requires that we know what our environment and natural resources are. And I would say traditionally, at least for the Red Sea, it's been a very understudied sea. The beginning of KFUPM in 2009 led to a significant uptick in the investigations in the Red Sea. I think there's been a longer history in the Gulf, particularly the center here at KFUPM has a long history of, does it go back at least 20 or 30 years of observations. So we need to know the baselines. What is here? What was here? And similarly, we're talking about global change. We're talking about the patterns and trends. We need to know what's going on in the environment day to day and over the long term. So baselines, what's there? Coral reefs. There's a huge, as I've already said, there's a huge emphasis on coral reefs. The NCW, SHAMS, the new National Organization for Coral Reefs and Sea Turtles, have as their one of their primary responsibilities the preservation of coral reefs. Traditionally, we've done coral reef surveys with divers. As you can see here, there's a group of divers doing a line transect. A diver can do maybe 100 or a couple hundred meters in an hour, and they're taking a census of what's there on the reef. Simultaneously, there are new developments. There's 3D imaging technology that's been developed. The Center for Environmental Imaging at UC San Diego has developed a system for three-dimensional imaging. So from that, we can get what we're calling digital twins. These are structure from motion images made of a reef off coast at Alpha Hall Reef, made by the Center for Environmental Imaging. But as you see, this is operated by a diver. So the limitations. One of my students is working on a project for imaging coral reefs using multispectral imagery from drones. So we can take this reef here off of KFUPM. You can see where it is in the Red Sea. And we're looking at just a very small patch. And we can look at it, but we can repeatedly map it with the drones. So we're getting a monthly survey of this reef system so we can look at how that reef is evolving through time. And if we take a single example here, you can see this patch of coral, and it's highlighted by the yellow box, and then that same area is shown at 2 different times. And I think it shows up pretty well. You can see the white specks from September 23. I told you that the temperature was 2 degrees above normal. And so we're beginning to see the bleaching occurring. Fortunately, later that year, another image showed that those particular corals have recovered. But in the southern part of the Red Sea near Jazan, that wasn't the case. From that same imagery, we're able to develop habitat maps. We're able to, and we're working now on technology where we can identify the coral taxa, and by segmentation, determine their area. And so we can do that for the shallow reefs. If we go to the deep ocean, the kingdom has a new initiative called Ocean Quest. And the Crown Prince desires that that will become the NASA of the ocean. With that, there's the Seabed 2030 Gebco Nippon initiative to map the sea bottom by the entire of the entire world by 2030. To date, about 25% is mapped. But mapping the bottom does not mean we know what's there. It only means we know what depth it is. So there are technologies like these remotely operated vehicles operated by a ship, and those ship costs can be at least $50,000 a day. And again, we're limited to a small area. Those are tethered vehicles. They don't move about freely. They're tethered to the ship. So there's a very high cost to the operation of those. And there are manned vehicles. In fact, I think that it was mentioned earlier about the Ocean X expedition that NCW sponsored. And that was a great effort to begin to set baselines for the Red Sea. And Ocean X has a small manned submarine that can take 2 people down, at least to, I believe, about 300 meters, but not down to the ocean depths. The Red Sea at its deepest is about 3,000 meters. And about half of the world's oceans are deeper than 3,000 meters. So autonomy is going to be needed in order to map and characterize the bottom of the ocean, to map our coral reefs. As we said, divers are not sufficient. So we have shallow vehicles, we have deep vehicles. A range of vehicles are going to be needed. They need to be agile because they need to be able to maneuver over complex structures. A critical thing is power supplies. We need to be able to, they need to be able to do multiple layers of imaging. They need to be able to do acoustic imaging, there's LiDAR imaging, there's regular visual imaging. Environmental sensing. Roxy showed some of the sensing that they're doing with the sail drone a few minutes ago. And we need that same kind of sensing for the deep ocean as well. And we need these vehicles to be able to operate as a fleet because we need to be able to cover large areas. So there's a huge need, and I think, you know, the kingdom desires to develop new industries and new technology. This is an area where we deeply need advanced technology to create new vehicles that are able to fulfill the needs of these kind of services. And when we begin to talk about environmental sensing, we had the National Center for Environmental Compliance earlier. We have got NCW that are all concerned about the quality of the environment and what's going on. So when we look at environmental sensing, we've got what I would call causative variables. Those are the variables of the environment that influence our ecosystems. They influence our biology, and where the biology, in some cases, the biology influences the geology through the development of coral reefs and carbonate structures. There are the diagnostic variables. Those are the variables that tell us about the health of the ecosystem. And under the causative variables, there are what I call the climate and environmental variables. And then there are the anthropogenic stressors. They may be some of the same variables that we look at in climate and environment, but they may have alternative sources. So temperature, salinity, the chemical properties, oxygen, pH, nutrients, are all important natural variables that we need to be aware of. When we look at coral reefs in particular, we think of coral reefs as very self-contained. The corals in the shallow water contain zooxanthellae that photosynthesize. So they recycle the nutrients that the corals produce as they go through their physiology and respire and discharge nutrients. The zooxanthellae take it up and they recycle it and they generate oxygen. That's not true for the deep corals, but that's critical. So the corals are also take subsidies from offshore. There's anthropogenic sources and what we might call pollution. In many cases, there are chemical constituents that may be regular nutrients, nitrogen, phosphorus, but they may come from agriculture, golf courses, whatever. There are pesticides that we use on land that often get into the ocean. If you have wastewater discharges, a lot of times there are endocrine disruptors and lots of things that can come in through the wastewater system. Heat can come in multiple ways. Power plants along the coast, desalination plants all have significant cooling water discharge heat through that. When we look at a coastal zone, we're developing a lot along the coastlines. When you look at the coastline, I consider the Red Sea is all, to me, coastal oceanography, because the Red Sea maximally is about 350 kilometers wide, not that wide. So everything's within close range, particularly then when we look at our coral reefs. They're very close to the coast in many cases, so light coming from the coast can affect them. And then sound pollution. Sound may come from boats, ships, lots of activities. There are what I call the diagnostic variables. Acoustics has been shown to be diagnostic of the health of a reef. Several people have been looking at this. So sound is very important. The natural sound. Camera imagery. We do normal visual imagery. We do multispectral imagery. We may want to look at just being able to visualize the reef, so cameras. So preserving it, how do we do this? First of all, I think we need to develop, particularly as we're developing the coastline, we're beginning to use it very actively. We need to sense the environment in real time. We need to be connected with it. I think our normal view of the ocean is we go to the coast, we like to be there at sunset, maybe on this coast sunrise, but you look out over the ocean and you see a beautiful ocean. You see the sunset or the sunrise. But that tells you nothing about what's beneath the surface. So we need to be able to connect ourselves with what's going on below the surface. So we need to understand the processes and trends that are affecting our environment. And then we need adaptive management. The National Sanctuary for Coral Reefs in the Hawaiian archipelago, this is the area beyond the tourist part of our Hawaii, but it's fairly remote in the Pacific. And NOAA is only able to get there every 3 years. So they do a survey once every 3 years, and sometimes they come back, and where there was once a thriving reef, it's now devastated. So we need to be able to respond to things in real time. We maybe can't change the climate trends immediately, but we have other things we can react to locally on very short time scales if we have the information that tells us what's going on. And so we need to optimize sensing for broad regional deployments. Again, we've talked about the agencies in the kingdom wanting to monitor the environment, wanting to preserve the environment in keeping with Vision 2030. And so when we begin to look at the sensing of the reef, we understand from the science that's been done already that multiple things affect the reef. Partly, when you dive on a reef, you see the reef, you see the big things. You see the reef structure itself, you see the fishes, you may see some, things like lobsters or shrimp or larger organisms, but there's a whole abundance of organisms that you don't see. So that one of our scientists, Dr. Susana Carvalho, has began to put out these arms units that they leave out for 2 years, and they look at what we call the cryptobiodiversity of the reef. As the physics is extremely important, the wave environment, the current environment to the reef. The water quality, that we think about things like temperature, salinity, chlorophyll, turbidity. As I mentioned earlier, we know that it's not only what goes on the reef itself, but the transport of material from offshore, the food supply that comes in, pelagic organisms. These can be zooplankton or phytoplankton that provide a pelagic component feeding of the reef. What's going on? There's chemical sensing. We talked about that earlier. So pH is extremely important. Carbonate, if the pH begins to go down, and we're seeing this with the pH in the ocean, as the ocean absorbs more of the carbon dioxide that we're emitting, the pH is dropping. That's affecting the ability of the corals to fix carbon, to make the carbonate structures. Always oxygen, nitrogen, phosphorus, iron, all these are important. We want to be able to image the reef. Fish population is very important to the reef. The imaging allows us to see the fish population, to see the other things on the reef, but very important that we understand what's going on there. As I mentioned, acoustic monitoring is important. It's shown to be a good diagnostic, and light. So we have all these things, and we'd like to measure them. Again, Roxy talked about autonomous vehicles. Besides something like the sail drone, there are some newer vehicles that not only can function at the surface, but they have the ability to dive, and they can go down to 100 or 200 meters. We combine that, we put sensors on that, we can have them map out the surface area, measure surface characteristics, but we also have vehicles that can dive and make similar measurements and do imaging as well. And I think I don't need to talk about this. Roxy already talked about some of this. Maybe a couple things he didn't mention is these sail drones and other types of surface vehicles can carry sonar that can do acoustic assessments of fisheries. And I know NOAA has done some experimental work, I think, using the sail drones that Roxy has shown in the US. I don't know, Arvold, if you have any experience with that in Norway. I would think, given Norway's expertise in fishing, they would be working at that too. But again, it's a way to, how can we do fisheries assessments without having to put out expensive ships? Let's see. And, with these underwater vehicles, there's new sensing. Not only can we do visual imagery, but we can now do excitation with other wavelengths. We can look at fluorescent characteristics. It gives us additional tools to look at the reefs. This particular instrument carries a LiDAR, carries an imaging system, and so we're able to get complex data, visual or optical data, back from the reef itself. So sensing the reef, to map it out repeatedly, we want to use underwater vehicles equipped with the imaging systems that we've discussed. We're also using aerial drones. As I mentioned, I've got a student who's working on this, and we're working with our computer scientists to develop the AI tools, and I think I mentioned that as well. And then we need to put sensing on the reef itself, and that sensing then has these multiple variables that I've just talked about. Measuring the currents, measuring the temperature, the salinity, nutrients, pH, O2, sound, camera, 2 cameras actually, one for just visual sighting, the other for measuring plankton abundance. When we get a system like this, we get a complex data set, and I don't want to bore you with the details of a data set, but you can see various data in here. The top line shows just pressure at 15 and 30 meters in the oscillations, and you can see the tidal motions very quick, but if periodic, occasionally you see, particularly in a shallow mooring, it gets a little bit more noisy. So that gives us information about the waves. This is just pressure, but we actually have an ADCP that measures the wave height, period, and direction, and also the currents over the reef, getting the current profile. We can see other events where we get low oxygen on the reef, or we get high oxygen on the reef that may influence its health. And then we see these periods when we get chlorophyll coming in from the deep chlorophyll maximum that are associated with food subsidies to the reef from the offshore. And then we get the current profiles, like I mentioned, sound, spectra, imagery. So we're getting all of these together. And one of the problems we're running into now is how do we analyze this complex data set where we've gotten all these kind of variables. And I'd like to commend KFUPM for its emphasis on AI. I think it's important that the students are learning to use this new tool. We were discussing last night, and there are also concerns about AI. Where will AI go? How far will it go? And could we lose control of it? The answer is possibly. But yet in order to manage the systems, we need to have the information. We need to be able to interpret it. Probably our standard ways of analyzing data are not sufficient, and we're going to need to incorporate these AI tools. And we embed that within a larger monitoring system. This is a coastal observation system that we're running off coast. We have a CODAR system that measures the surface currents, and we have underwater gliders that maintain a sustained line off of coast. So we're running this line continuously from the coast out to near the boundary of the EEZ, and we're running it. The glider goes from the surface down to a maximum of 1,000 meters. So we're able to map out temperature, salinity, oxygen, chlorophyll, CDOM, suspended particles. And this is part of a system we've set up at KAUST for what we call for testing and developing a system. We have the observation network itself. We have a particular area we're working in, which is a test bed where we can take equipment and test it out. And the idea is that by looking at these systems together, looking at the data set, that we figure out what's an optimal set of data that can be obtained. We hope this will be of value to the kingdom so that the kingdom can design a national monitoring system that's coherent, consistent from place to place, and has a data set that can be unified together so that we can understand how the system is working. And so when we look at this, we've got a system with offshore sensing, we've got the reef. How do we put it all together? As I say, we're going to need the deep learning and the artificial intelligence tools to understand the patterns, the trends, maybe look for the subtleties, and perhaps we can set this up so in a long-term system, the systems are operating in real time so they can inform the managers about what's happening. So standardization is really important, I think, for setting up a monitoring system. We need to, and so we're using the AI tools to analyze the in situ data and getting a time series of repeated image mapping of coral reefs or marine habitats in general. And then from that, we can determine what variables are most likely to inform us about the health of the environment and trends. If we think about coral reefs, traditionally temperature has been the primary variable, but if you talk to any coral reef biologist, They will tell you there are other things going on. It's not just temperature. Are there other stresses that stress out the ecosystem and make them even more vulnerable than they might be? So I think I've said this is standardizing the key variables. And so the goals of our smart reef are to provide a foundation for long-term observational network that will provide key insights into the functioning of the kingdom's marine ecosystem. Provide real-time information about natural and anthropogenic factors that can impact coastal habitats, thus enabling managers to take immediate action to mitigate ecosystem threats. And this could be a nutrient input. Before coming here, I worked I did a lot of work with the water agencies in Los Angeles, and a critical problem there was they discharged almost 1 billion gallons of treated wastewater a day. Let's see, 1 billion gallons, so 4 billion liters almost a day. So a lot of wastewater. And we saw negative effects over time, and as a result of that, it became clear that we've really got to minimize the influence of that kind of discharge in our new developments here in the kingdom. And often accidents can happen, pipes can break things. And if a manager knows about that sort of thing sooner rather than later, and if we can detect the signatures from those, as a system like this could provide, then we could get to the answers very quickly. And then create a long-term observational network that allows us to look at the ecosystem connectivity, look at climate change, and just provide a real-time connection between ourselves and the ocean that we live in the context with. And we link this in not just to a local monitoring, but to a larger ocean observatory that provides a larger context for what we're looking at. So with that, I'm going to stop, but I'd like to make one final comment. Again, Ben Horton gave a fairly urgent message yesterday. And I think the kingdom has a really strong opportunity here. Frederick Taylor, who took over the atmospheric science program at Oxford when John Houghton, who led the the scientific team for the first three panels on climate change, Frederick Taylor wrote an obituary for John in the Nature Communications. And in it, he asked John Houghton, are you in despair because of what you see, what you've learned through all of this? And Houghton's response was, absolutely not. His message was, there is hope, but the hope is we have to take action. I think through his career, he saw the frustration of going to repeated meetings where discussions were made, where agreements were made, but no action taken. I think the kingdom has the opportunity here to provide an example to the world by taking action, and in their developments, showing the world how things can be done better. With that, I will stop, and thank you.
Thank you, Professor Jones, for instilling hope in us. Moving on, there's a slight change in the program, so we are going to start the next talk. So, ladies and gentlemen, it's my pleasure to introduce Engineer Sultan Al Rushaid, the Safety Superintendent at Maadan in Eastern Province of Saudi Arabia, a graduate in Chemical Engineering from Kansas State University. Engineer Sultan has enriched his professional journey with certifications in NEBOSH, Environmental Management and Radiation Protection Program. His tenure at SABIC as an EHSS engineer laid a solid foundation in health and safety, particularly in managing radiation activities in the chemical complex. At SABIC, Engineer Sultan was instrumental in handling turnaround projects, driving forward waste management initiatives, and significantly contributing to the enhancement of HSE culture. Since joining Madan in April 2023, Engineer Sultan has continued to demonstrate his passion for solving chronic HSE issues. So we are fortunate enough to have Engineer Sultan Al Rushed with us today, whose expertise and dedication are invaluable assets. So please join me in welcoming him. Engineer Sultan, the floor is yours.
Assalamu alaikum. It's a great honor for me to stand in front of you in the GiKS conference. I would like to extend the appreciation and the thank for the KFUPM to arrange such event and to bring a diverse group of expertise and professionals to speak on a very noble matter that's for us and for the earth and for the next generation, inshallah. So, for today, I'll be covering the aspect of the phosphoric acid manufacturing and the environmental challenges associated with that manufacturing in the process, and how we did link that to the smart technologies to overcome the environmental challenges in the process of it. So when we talk about the environmental monitoring, especially in the oil and gas or mining and petrochemicals industries, we look at how the organization is impacting and the activities of those organizations impacting the environment, either negatively or positively, and we try to monitor those aspects from environmental point of view in order to minimize the impact of the negative ones at least. So, for our topic, the smart technologies, when we link that, the environmental monitoring to the smart technologies in the industries, we use technology to make our life easier, faster, more accurate. We gather data that we analyze automatically, and we get decisions right on the spot. So when we think about environmental monitoring, we talk about having faster ability to get those data and analyze them to take automated decisions that will alert us on a situation that is unhealthy for the environment or the human being, right? And we can use that technology as well in order to use the natural resources in a better way that is more efficient for us and ultimately have a clean environment that we can have, and we can say we have a sustainable operation. So this was covered already by Mr. Alayan and Mr. Zahrani for smart technologies and their applications around the globe. I would just like to take an example that I encountered during this preparation of this presentation in India, where they incorporated all these drones and remote sensors and the geographic information system in monitoring the crops in the land in India, right? In a way that to reduce the amount of natural resources such as water in the irrigation system. So what do? They take the remote sensors from the drones and the picture from the geographic information alongside with the information from the weather forecast in a way to see where to irrigate more corresponding to the wet and dry lands. That's such a great example that we want to implicate or mimic in our industries. So from the industry that I come from, phosphate business unit, we operate to produce phosphoric acid, right? So why phosphoric acid is important for you? Phosphoric acid play a crucial role in the production of the commercial phosphate fertilizers. Phosphoric acid can make the soil fertile and make the soil release more nutrition such as nitrogen and potassium, will make the crops healthier and grow faster. And ultimately, it's very important for us in Saudi Arabia and other dry countries that it will help the soil to retain the moisture. So this is why the phosphoric acid is very important for us to have a sustainable, because we want to have food stability and security around the globe. And fertilizer definitely helping in the process. So In 2012, the manufacturing of the phosphoric acid started in Ras Al Khair. In the eastern part of Saudi Arabia, the manufacturing of phosphoric acid started where we extract the rock phosphate at the beginning stage from the Hazm al-Jalamid, the northern area. Rock phosphate is being extracted from the ground and transported to the east side of Saudi Arabia in Ras Al Khair to be manufactured. Throughout the process of manufacturing, rock phosphate is being crushed, then mixed in reaction tanks with the sulfuric acid in order to produce phosphoric acid that will be later on processed to make fertilizers. Things were looking good. From 2011, production was good. Ma'aden was able to cover 16% of the world demand from the fertilizers until 2019. In 2019, we encountered a new problem, a problem that was unheard of the phosphoric acid or phosphate business unit production. As you can see in the picture, there was a pink emission. In 2019, it was the first time that the pink emission was observed in a phosphoric acid in Saudi Arabia. We did the benchmarking with other Saudis' phosphoric acid units in order to see what is the root cause of this. None of those sites have encountered such thing. We expanded the research to Africa, USA, India. None of those phosphoric acid plants had the similar issues, except in China. In China, there was one location that had a similar issue. And throughout the communication between the company in China and Ma'aden, they have concluded that it was the iodine that affecting the quality of the rock phosphate that being extracted from the mines that will ultimately have the pink emission there. So we have collaborated with our partners in KAUST to do the research and identified and confirmed that yes, the rock phosphate that we are using in Ma'aden has a high content of iodine, right? Now the thing is, why did it only start in 2019? Throughout the process of the mining, the locations of the mining has changed over the years. So the iodine content from location to another has differed, which has affected the iodine level in the process. So we have communicated the plant in China, right, to what technology they have used. And in China, what they are using is to recover the iodine. So the team in China has came to Saudi Arabia, and they spent 1 year working closely together in resolving this issue. However, it was not feasible for us in Saudi Arabia to recover the iodine due to space limitation that was not feasible on a commercial scale. But after 4 years of research and development with multiple vendors, we have found a groundbreaking solution or solvent that was patent, that was used to react with the iodine in the process in a way that will convert it into food iodide. So in the process here on the graph, you can see the mixing nozzle where the solvent unit is mixed with solution and dilution. The solution will go into the flue gas, will mix with the iodide, and will convert it to food iodine, and then it will go as a clear fume gas. This is a picture of what we had before and what we had after. The environment and governmental was not very happy when we had the pink emissions, and they were knocking on our doors every day. But alhamdulillah, in 2023, we have succeeded in to eliminate and remove the pink emission. So where are we going this? How can we make this process even smarter? So currently, the process is that the dosing of this solvent is constantly being dosed to the system. And through manual and visual from the patrolling of the operators at the site, they would see if the pink emission is very intense or higher, and they will demand that we increase the rate of dosing. Now, what we are going forward to see, and what we are planning to pilot on the April of 2024, that we are using the AI cameras that will be directed toward the stacks, and which will monitor the intensity of the pink color, and will correspond to the rate of dosing for those for the solvent being in the process. Inshallah, in April, it's going to be another success story for us that we're going to be implemented on Traif and in Hazm al-Jalamid as well, and all the other affected location with this pink emission. Thank you very much.
Thank you, Engineer Sultan, for the wonderful presentation, especially the conversion of flue gas to food iodine. Now, our last presenter is Dr. Mutas Al-Baladi. Dr. Mutas Al-Baladi is an accomplished professional with a multifaceted expertise in simulation, research and development, air quality management, and finance. So he currently excels as a simulation and R&D director at SAIL and plays a crucial role as the air quality and radiation manager at NCEC. So he is holding a PhD in environmental modeling. Dr. Mutas has extensive experience in applying advanced modeling techniques to evaluate and address environmental challenges. His academic and research pursuits have endured him with a profound comprehension of intricate environmental systems and ability to develop innovative solutions. His academic accomplishment equips him with the tools necessary for effectively overseeing air quality and radiation initiatives at NCEC. So overall, Dr. Mutas is a dynamic professional with a robust foundation in simulation, research and development, air quality management, and finance. So his blend of a PhD in environmental modeling, a master's in air quality modeling, and an MBA in finance and strategy positions him uniquely to address environmental challenges from both technical and strategic standpoints. Dr. Al-Baladi's diverse expertise sets him up to make significant contributions in environmental engineering and sustainable development. With this short introduction, I would like to welcome Dr. Mutas to deliver his talk.
Yes, Assalamu alaikum. Actually, I'm the last speaker, so I'm trying to make it quickly. Actually, we are in SAIL. We were established in 2022, 1st of February. We were established by a royal decree. We working closely with NCEC for the oil spill response. Actually, our mandate to establish a 530K barrel oil response. I'm trying. Okay. Yes. This is SAIL value chain. We start from monitoring. Actually, this is just a concept. We already opened our monitoring room in the last September. We using multi data source like drones, radars, high frequency camera. All of this data goes to our monitoring room to do the process. Actually, what makes SAIL different than other like entities or any companies? Actually, our monitoring room powered by AI. We already now using the AI for the detection, for modeling as well. After that, we go to the contaminating. We contaminate the oil and then recovery. And this is more operational, so I will go to rehabilitation and documentation. And then after document who is responsible for the oil, the whole file goes to the regulator, which is NCEC. So technology, our technology, what we are using. Actually, we're using, as I just mentioned, like we using drones, short and long-range drones, and we have like a mobile truck which is in the middle. It's actually sounds more military, but that's why we need it, because we go very in a remote area. This mobile truck equipped with drones, short-range drones, and diving equipment to do the studies if there is any damage or oil spill damage for the environment, for sure. The real-time monitoring, we start with the satellite as an induction, and then with actually our solution, it's complete solution: satellite, drones, and radars, and the cameras all together. Compare with the whole data goes to the monitoring room, do like actually doing like analysis with the AI and all of this stuff, which is make it like we doing like a trend. Actually, for now, we know where is the potential area of spills, and actually there is like a hotspot. Mostly all the vessels like doing this here and there. Like we know, because like we've done the study over 3 years. Now we have a baseline. Where is the oil spill, and we doing like we focusing in this hotline. So this is what is the real-time monitoring, and we have the monitoring room as well. We have the trajectory modeling, which is to predict where is the spill is going to, and because if we know where is the oil is going, based on the data set that we have, we will know is it this like sensitive area. For example, if we have like a mangrove area, this is a high priority to protect it by deploying booms and all the equipment. As you know, this is the traffic map, the Arabian Gulf and the Red Sea. Actually, in the Red Sea, we have more than 25 vessels per year going for, it's considered like a logistic area. Okay, AI. Actually, there is a lot of, let's say, I will take like modeling as an example. We have a lot of softwares in the market for oil spill, for example. But most of them don't use the AI. And why do we use AI, actually, from the beginning? Okay, enhanced detection, real data processing, and optimizing response strategy, which is, we call it like decision support system. How we give the spiller, how to give the best scenario to response in emergency. Okay, we start using the AI from detection and classification and protection as well. In all this stage, we use the AI to maximize the use of these data we already captured. The oil response and the damage control as well, how we control the damage if there is any damage, and emergency plan. This is how the AI gives the best scenario to response. Okay, actually, this is one case that we applied the AI in our system. We already now, this is a case, we have done it. As you see here in the left, this is a satellite image that we capture, and then we detect an oil and we classify the oil. And then we've done the modeling, as you see in the other side. The model start to run and start to make, like, as you know, there is always a mistake in prediction in modeling. So as you see here in the actually how we done this study, we get like a serial of satellite image, one before the spill and the other during the spill and after, and we keep monitor it, and we calibrate our model to see is it correct or no. So as you see here, and the yellow, it's the next position for the spill, and the gray is the previous position, and green after the drifting, the forecast. As you see, the model corrects himself and continue to correct himself. And this is another, this is more clear in this case. You see the model corrected himself. Okay, thank you for listening. And we have like a short video explain what we are doing. Thank you.
Oil spills are a global problem that can have devastating impact on the environment and the economy. The oil spill industry is responsible for preventing, responding to, and cleaning up these spills. It is a complex and challenging field, but it is also an essential one. Where SAIL's role is to protect the Saudi exclusive economic zone. And artificial intelligence has the power to transform the oil spill industry by providing faster, more efficient, and effective ways to handle such situations. What is AI? AI is a technology that allows computers to learn and perform tasks that would normally require human intelligence. It takes data from many sources and processes it to generate solutions. SAIL team has many different data sources that we will use to train AI models. These sources include satellites, drones, radars, marine sensors, CCTVs, oil trackers, and mobile trucks. Using these data, we can develop different solutions that help in detecting oil spills, predicting its fate and trajectory, more accurately than ever before. Using AI can also help us in emergency response, emergency planning, decision-making, and damage control. Our ultimate goal at SAIL is to revolutionize the marine operations for environmental services industry. By developing state-of-the-art AI technology that will set a new benchmark for keeping our water safe and clean.
So we have come to the end of the session, and I would like to invite Engineer Adnan, Professor Bert Jones, and Dr. Roxy onto the dais, please. Okay, let's start the panel. So if you have any questions, you can please raise your hand. That's it. That's it.
السلام عليكم. ما أدري الصوت واضح؟ I am Najla Al-Mutahiri. assistant professor in economics at King Saud University. Thanks for this first of all session. I have two questions for Director Adnan. The first one is, what do you think, you talked about the role of technology or advanced technology in environment. What do you think the role of center in improving the environmental quality or economic complexity or complex manufacturing industries that are less pollution compared to oil manufacturing industries? As I did paper on economic complexity and ecological footprint, and the result found that economic complexity can reduce the environmental damages in Saudi Arabia. And also, what are the challenges maybe in the long term faced in this issue? Although Saudi Arabia has a progress for the economic complexity index. The second question is, you mentioned in, developing our local manufacturing can attract foreign investments. But on the other hand, FDI or foreign investments can also help in reducing the environmental damaging by transfer the advanced technologies. What the restrictions that imposed on these foreign companies by the center? Thank you.
Thank you so much. Very good two questions. The first question is about what are the mandates or what the NCEC do to let the other sectors get engaged. NCEC is an entity that responsible for monitoring the environmental compliance from other entities. For example, you mentioned something like oil spill or something like this. Let's say we have an oil spill somewhere in the ocean or the sea. NCEC is not responsible to remove that oil spill, rather reviewing the plan for responding to that incident. And we verify that plan. It is environmental and it's gonna eliminate the problem. And the execution is actually by other entities. For example, SAIL is one of the entities that does that. So NCEC actually do the monitoring instead of the actual work, the operational. So this is the first part of the question. I hope I answered it. If not, I can elaborate more. The second question was, if you remind me of the second question again, I'm sorry.
What other restrictions are imposed on the foreign investments to comply?
Yes. Yeah. Okay, so we encourage the local investment. Well, the country actually does that, and we are part of this. But we take it from the perspective of technology. We have to make sure the technology is made in Saudi Arabia. If not, then yes, we have to go outside. But our main goal is to encourage the local content. And we work on establishing laboratories within the institutions or research centers, like, for example, KAUST and KFUPM. We also do some sort of workshops for the manufacturers to take into consideration and calculation the environmental technology into their manufacturing. For example, General Electric, if they are willing to establish or open a company here, then it has to fulfill the environmental standards and regulations. That's basically what we do. I mean, one of the things we do.
Assalamu alaikum. I'm Muhammad Shafiq from Center for Environment and Marine Studies. I have two questions. One is to Dr. Roxy. You were talking about the impact of marine heat waves and the subsequent extreme weather events, especially in the Indian Ocean and in the Saudi Arabian continent also. So I am a little bit concerned about the fisheries side. I know you did already some work on Indian Ocean warming and its impact on marine productivity and the fisheries side. Also, you have mentioned in during the morning panel session that you did some work with the tuna data. So, do you have any comment on the variation or the impact of fisheries side for the marginal seals like Arabian Gulf or Red Sea, whether the Indian Ocean warming that have a direct impact on this side? My second question is that is common, anybody of you can answer. When we look at the world ocean, we have a lot of mode buoys for the in-situ data collection. But when we look at the Red Sea or in the Arabian Gulf, we have very limited number of mode buoys in the region. Can anybody answer why this scarcity for in-situ data collection? Thank you.
Right. So I will start with that first question on marine heat waves impact on fisheries, ocean warming impact on fisheries, and so on. Thanks, Shafiq, for that important question on connecting between these different elements. Across the globe, there has been a handful of studies, I would say, connecting marine heat waves and mass fish mortality, actually. Yeah. So this has been identified along the US coast. Actually, some of you might have heard about the Pacific blob. This was a huge marine heat wave over a large area in the Northeast Pacific, which lasted for more than a year. Yeah. So there are marine heat waves spanning out a few days, 2 weeks, 2 months, or sometimes a year too. Yeah. So this is not periodic, and this kind of extreme events have led to mass fish mortality in regions like we know that there is a strong connection between these extreme temperatures and degradation of marine ecosystem, including fisheries. Now, in the Indian Ocean region, there has been studies along the Korean seas where they have identified similar mass fish mortality happening along with marine heat waves. Yeah, but beyond that, I would say the marine heat waves research study and modeling study is still in its infancy. That along with the availability of fisheries data, which sometimes is quite difficult, and many times one is with the physical, one is the domain of the physical oceanographer, where the other is the domain of the biological oceanographer or the fisheries sector. So it becomes quite difficult for many researchers to put them together and make that understanding. So we have only a very handful of studies, but we see that it's highly possible that this kind of mass fish mortality is happening at many places which are experiencing this kind of marine heat waves. Yeah, and this has been identified across the globe, marine heat waves in the recent periods, and it's increasing. In fact, in one of the reviews that I am leading for the larger Indian Ocean region, we see that with respect to the current state, by 2050, Indian Ocean will be in a permanent marine heat wave state. Yeah. So these are the kind of situation that we are going to face. So how will be the fisheries be? Definitely they will be affected. We see other kind of nuanced or complicated impacts in the Indian Ocean and even the coastal regions as well. For example, the Arabian coast, the west coast of Arabia, close to Saudi Arabia as well, where increased ocean warming, particularly which is more on the surface, is leading to stratification. Yeah, so less dense water, less dense water on the surface. So there is less mixing with the nutrient-rich subsurface water. So that prevents, growth of phytoplankton. So there is some decrease. We are able to detect with the satellite data over the last 20 plus years. We see there is a detectable reduction in phytoplankton production or primary productivity over the larger Arabian Sea region, which might potentially cascade to the fisheries as well, because we see some of the larger fishes like tuna or other fishes may not directly depend on phytoplankton, but phytoplankton is consumed by zooplankton. Zooplankton is consumed again by the new recruits or the fishlings. Yeah,
the pelagic fisheries.
Yeah, yeah. So that way it connects to larger fish population as well. So these kind of impacts are there. Now, I'm not sure if you have seen similar kind of marine heat wave impact on the Red Sea. Actually, this is Red Sea or even the Arabian Gulf. This is actually something I wanted to ask Burton as well. Are there similar kind of marine heat waves observed in the Gulf Seas, Arabic Seas, and actually I wanted to follow up with a different question, but I don't want to be carried away right now. I will keep that for later. But I think I answered a bit of what you asked about. Thank you.
Yeah, thank you.
Let's see, I think your second question was, why aren't there more moored buoys in the Gulf and Red Sea? Is that correct?
Yeah.
Okay. Moored buoys are, when you think about what a moored buoy will obtain, it's at a single point, and it will do an excellent job of giving you a time series of observations at that point. Now, if you're running a four-dimensional computer model and you correct your model with that one point, you're not providing a representative point you're only giving one point. And so its ability to correct the model when you're doing a data assimilation model is minimal. Many of the things that we see in the ocean are spatial processes. We have eddies, we have fronts. And if you look at both the physics and biology associated with them, they're very three-dimensional, and we want to understand those processes. We have found, at least in my work, I prefer to use autonomous underwater gliders that can move through space. They can do repeated surveys along a line. So if you think about it, we get repeated profiles at different points along that line. We can create a time series at a point from that. But it gives us spatial information as well as temporal information. We don't get the high frequency temporal information. And if that's needed, then you'll need to put in some kind of a fixed site. Now, if you're looking at, let's say if you're working in a shallow shelf and you need to understand resuspension, and you need to understand how waves affect it, then you may want to fix buoy and doing a time series measurements. But if you're looking at sort of larger scale ocean processes, the gliders, the Argo and BioArgo float programs give us a much broader scope of observations. And so it really depends what your goal is. But I guess, as I say, where I'm at, I think, and if you want data to go into models, the gliders and the floats offer a more cost-effective and a broader area of information that will actually have a much better influence on the data assimilation models than just a single point.
Okay, thank you. Thank you for this.
Any more questions?
السلام عليكم ورحمة الله. محمد العيدروس من الناشونال سنتر فور فيجيتيشن كفر. وهو سؤال والثاني كوميتمنت أو لا إنه بملاحظة. السؤال بالنسبة للأخ your colleague, okay, he mentioned that the Indians have employed the AI, okay, to find the irrigation drainage or so I wish he used the NCVC initiative to use the AI. We are, as the NCVC has a pioneer using the AI to monitor the vegetation cover in Saudi Arabia. As you know, Saudi Arabia is 2 million square meter, and we are mandated, okay, to monitor 70% of this area. So we are monitoring 1.7 million square kilometer, which means 170 million hectare. So it's our fault that we did not participate in this forum. We have a very good experience, and we have employed algorithms that monitor the healthiness, okay, of the vegetation cover, and we are in the middle of this project. It's a mega project, cost us as 100 million of Saudi riyals. So this is we are proud of it as NCVC employee and as a Saudis. The other question, as the NCEV, you are proactive, okay, to prevent our environmental. So if the oil spill happened, we have to have a regulation or strict regulation to the vessels or to the oil ships, okay, to be a resilience to this factor, because we know that if oil comes down to the sea or oceans, it will destroy, okay, the life in the oceans. Thank you.
All right. I didn't catch your name. I'm sorry.
محمد العيدروس NCVC.
أهلا وسهلا. Thank you so much, Muhammad. We are aware of the project of the NCVC, and we work together with the NCVC and other centers as well, and other entities in terms of technology. As I mentioned before, our job is to collect all the technologies possible in the Kingdom of Saudi Arabia, and I would say validate them first and then verify them, right? So we are aware of the project, and I just talked to my colleague that we need to meet with all of those people who mentioned technologies so that we can come up with new ideas or even an SOP, who knows, or a mechanism of how to verify technologies. So your point is noted and taken for the first part. The second part was the AI, the proactive proactivity in terms of dealing with future deviation, if I would rather say. We do not have the proactivity now as we are working on the technologies. What I mentioned earlier is that we have to have technologies that helps us be proactive. The technologies are there and under the process of assessment. Once we got all of these studies and papers, we go and review them, and then we validate the technologies, and then we can say, yes, we are ready to be proactive for any deviations or any potential or future problems.
Thank you so much, that's all.
Yeah.
Assalamu alaikum. I'm just would like to share some of our thoughts, and we need to hear some comments from you. Actually, we are asking ourselves, what is the technology that we think is new for us? What I can see either from cameras, drones, ROVs, whatsoever sensors, I can tell that we are doing system integration. So we are buying all these components and we customize it in such a way that can serve us in certain purposes. And then we can bring either image processing, signal processing people, artificial intelligence to do some work. So the question that this is, I would like to have an answer. What is the next step for us, more than what, up to my knowledge, what I have said? Thank you.
Just to continue the same approach, do we have a sort of standard or guidelines how to control this kind of new activities being born in Saudi market lately based on our environmental demands high for different cases we are facing: air pollution, water pollution, and soil pollution. Thank you.
Now, should I take the initiative?
Okay, thank you so much. Two important questions. The next step that we need to work on, first of all, we need to understand the difference between automated technologies and autonomous technologies. What we have so far is automated. Like we have data, raw data, turn it into indicators, and then from there we give the system these indicators to act upon. What we are aiming for is to make everything autonomous. And autonomous means the system runs the data by itself, analyze it, and initiate solutions by itself, all by itself. So this is what we are looking for so far. I know this is a huge step and it will take time, but with help of from all the entities, yes, we can reach to that point. So this is the next step so far, I mean, from my basic understanding. For the guideline, yes, and I was thinking of putting the guideline we have posted in the website of NCEC here, so for people to see and know what the requirements and standards that we are looking for in terms of assessing technologies. Yes, maybe we made a mistake. We didn't put it there, but anyway, it is there. We have a regular we have a guideline. We have requirements posted in the website, so people know what to do and what are the environmental technologies that we believe they are eco-friendly based on these requirements.
Yeah, I was going to talk later. You know, talking about sensors and innovation. You're right. Some of what I talked about is integration. And probably what's new in it is the way we integrate things, in that people have not integrated the sensors in this kind of combination and looked at them in this way combined with the imagery before. So that, and that is a type of innovation. There are other places. We have things we want to measure, we can't, or the sensor does not yet exist. And so that's an area of development. The other one is in autonomy. We're talking about needing new vehicles in order to map out the marine habitats. There are two parts to the autonomy there. And that is, there's a need for enhanced intelligence in the vehicles to be able to both visualize the environment they're working in, position themselves accurately in that environment, and navigate and maneuver in order to achieve the goals that those particular devices have been given. The next step up from that is we're looking at how do you manage a fleet of vehicles working together. And this is, I've been working on that side from the oceanographic side, where we couple it with ocean models. And we begin to look at the uncertainty in an ocean model. How do we then create a smart system where the fleet of vehicles are manipulated in collaboration with the model to minimize uncertainty and error in the model and to optimize the output. You know, these are some areas in autonomy that need addressing, you know, that need advances. As I say, we need it both in, there are things we can't measure that we want to measure. And that's where we're going to we need people to create the sensors. That's a combination of electrical engineering, some chemistry, you know, various kinds of things. So that's it.
So I would like to add a few lines to it. So I already saw in the first few days, I saw the KFUPM showcasing the advanced technologies and instruments that you use, and I'm happy to see that. But along with that, along with the pursuit for advanced technology, I would like to enlighten upon this side of observations and understanding. So early on, Button was saying the ocean is you have to approach the ocean as a living element. So the currents are moving, the fish are moving. So which means that, okay, you have an advanced technology, but it's not just the coastline of Saudi Arabia along the Red Sea or the Arabian Gulf that you need to monitor. You need to monitor the other side of the Red Sea and the other side of the Arabian Gulf as well. If you want a comprehensive understanding of these two basins, if you want to have a comprehensive understanding of the marine resources, how they move, how they work around, and you know, extract the resources from there sustainably, and that would need new strategies, new partnerships. So, and there, probably Saudi Arabia can be a leader of this region in terms of observing, but at the same time bringing other countries together so that we can have a comprehensive observing system in both the Arabian Gulf and also the Red Sea. So that's how I see this moving forward if you are looking for a sustainable green future. Yeah. So that's the kind of new strategy and new partnership. So I think that's quite important.
Thank you. This is the last session, so I'm going to allow myself to go off script and maybe pose a question, a reflection over the last couple of days. We've listened to passionate talks all throughout the last couple of days and very informative and very, really expanded every horizon and every dimension. We listened to climate, we listened to the sustainable development, we listened to various ecosystems, and marine and terrestrial. And I'm reflecting on the theme of this conference, which is sustainable development and the future. And I'm gonna pose a question. I don't have the answer, but maybe we can together start approaching that. Do we need a coherent agenda, us being the scientific community generating data, to achieve sustainable development? Do we need to have a coherent agenda? I mean, we come from different disciplines, and this is a great media where we have scientists, engineers, and looking at different aspects of this massive development issues. How do we approach sustainable development? In my mind, there has to be a coherence, that there's no platform to talk about coherence in the scientific community, that we all drive towards and row in the same direction. Do we need that? And how do you approach sustainable development if each of our discipline is rowing in a different direction and not building on other disciplines to move forward with the needle? Just a reflection, maybe some of you can reflect together on that.
I'll just initiate the discussion. I think it's that coherence and integration that Burton was initially, partially talking about, integrating different disciplines. And I see a huge need for this because whether it's understanding or moving towards the sustainable future, we need to be not just interdisciplinary, we need to be transdisciplinary for that to work out. And we need different departments, different ministries to talk to each other. But I don't know how to achieve it because you know how a scientist develops his career. It's quite narrowly focused. So one person works on one instrument. For his lifetime, he might be working on that instrument. In my institute, I have people working on the size of a raindrop. For 15, 20 years, he or she will be working on the size of the raindrop. But we know that in nature, all these elements, different elements, the atmosphere, ocean, biology, atmosphere, land, everything works together. And if we need to monitor, forecast, or build resilience in a sustainable way, we need then engineers, policymakers, administrators also working together with that. So how do we approach that? Probably we need to start with our education system, and as university, KFUPM and other universities here have a wonderful opportunity to tap into that transdisciplinary approach, which breaks into, brings together the science, the engineering, the policy all together. Maybe that's how it starts, and with people with vision that can be done, I feel.
Yeah, and I think, I'm in a science and technology university, and my roots are in engineering, I think that when we face sustainability, the reality is the answer is simply not the technology and the science. We've got to be working together with the people in policy, in government, the people who can make decisions. We have to come to the reality that we're all on the same team. And, I mentioned John Houghton earlier. It was interesting, John Houghton also saw it, he was a very spiritual man, and he said, it's a God-given responsibility to us to protect the gift of nature that we've been given. So we've got to somehow incorporate this into our whole line of interaction somehow, that we move together, united among not just the scientists working toward a goal, but working with the government, working with the policy, working with NGOs, and working with somehow getting the people on board to love this earth that we've been given to work together.
If your concern is about a local action, like in Saudi Arabia, then we have started working on this, which is through the SGI, Saudi Green Initiative. This will help approach or achieve the Sustainable Development Goals. I know the goals are interlinked with each other, integrated as well. So we worked on the SGI, which unites all the entities, sectors to work together in order to achieve the goals. If we want to talk about it internationally, then we have also invented the MGI, Middle East Green Initiative. That one has been announced, I think, 2-3 years ago, if I'm not mistaken. And I believe we have over 32 countries, not only within the Middle East. We have countries even from South America, for example. So it's an international initiative, and we worked on this. So I would say we did, I wouldn't say we did our part, but we did something on this matter, and we will keep working on it. We also, I have to mention the international conventions. For example, UNFCCCs, we have the UNEP programs and all of that stuff. So we are members of all of these initiatives and activities that will help achieve the SDGs.
I think we're just about out of time, so this will be a quick question, but a question I'm interested in. The world's really been interested in this concept of planetary boundaries, and I'm just interested to know from the panel, this idea that we're approaching critical thresholds, is this just something, is this just a concept, or is this something that's founded under good measurement? Is this something that technology should be geared for now to measure and to quantify? Because the United Nations, major international organisations, are actually describing their sustainability programs in accordance with this concept of planetary boundaries. I'm just wanting to know the panel's thoughts about it, and if we can't measure it, what is the true utility of this concept?
I'm not sure if I understood you totally, but I got the point on tipping points. And I would say we already have some examples on how we are approaching tipping points, and probably some quantifications already have been done in that. And for example, it's about the Arctic sea ice melting. Studies show that in the very near future, maybe in a decade or two, we will see ice-free Arctic, probably in some months like September. Yeah, that's in the peak of northern summer. So these are like tipping points we are already approaching. We see we already have the data on how we are progressing in that direction. Some quantification has been done already, and with the best available models, it shows that, okay, we are going to have a tipping point beyond which there is no coming back, probably, because with the current state of emissions, the temperatures are going in that direction where, the carbon dioxide will remain in the atmosphere for long centuries ahead. So there is no coming back from that. So we would need to identify. So there are other tipping points. Yesterday, Horton showed a picture with multiple tipping points. So I'm not sure how well quantified are the other ones, but this is one of the best examples. We need to quantify the other ones, and many of them we are not sure when the tipping point would be, or if there would be a tipping point. Yeah. But for one thing is for sure, ocean acidification is happening at a rapid pace. It's already affecting the size of the marine ecosystem which have those exoskeletons. I mean, these corals and shells, they are growing smaller and smaller because they cannot make their shells bigger because of acidification. So that's kind of a irreversible change that we see, because we are not going to, remove the acidification of the ocean all of a sudden. So, and we need to quantify that. That also is not well quantified, well observed, well monitored. Yeah. So this is based on whatever bits I understood from your question. Others can join you.
Thank you. I think the tipping points is the example, a good example. The real question is tipping points or planetary boundaries. These things are so important for the discussion globally around sustainability. My question, just to clarify, this is a discussion about sensors, technologies, modeling.
Right.
What I'm asking is, do we have the capacity to actually quantify these concepts now? Or is this something that should be a global mission in your fields that we need to actually address? And I think you've given a partial answer. Some of the tipping points we do have the capacity and we have certainty, and some we don't. So I'm just interested, is this something we need to invest more in? Or is it just a concept?
Definitely, and not only in monitoring, but also modeling, because at the present moment, I mean, it's quite difficult to monitor each and everything, and whether it's the ocean or the atmosphere or the entire climate system. If you want to put it together, we need the observation coupled well with the modeling. Both should go hand in hand so that we understand these tipping points better. So even if we are talking about sensors, observing, monitoring, and so on, we do need that modeling capacity which will supplement or complement it. That's essential if you want to identify these tipping points and work towards sustainability. Yeah.
If I would add something to this, I would say nothing is not measurable. Everything is measurable, but with data. And I know some data is not robust, reliable. For example, IPCC used to have BUR, if you know what that means, biennial updated reports, and they have data in it. Now we do have BTR, transparent reports, which encourage countries to be more transparent in order to reveal their data. So I would say, yes, it's a field of improvement. We need to work a little bit more on collecting data in order to start measuring the tipping points. I also have, based on my experience, that satellite imaging and drones now are some of the ways of collecting data. Yes, they have pros and cons, but we are still working on enhancing the technology of collecting data and measuring and analyzing as well.
Dr. Mani, here, I have a quick question to Dr. Yeah, so I want to end this in a very positive note. So you worked on the Red Sea corals and so on, and I see a lot of coral bleaching and coral mortality in the Indian Ocean, larger Indian Ocean, including the Coral Triangle and the Indian Seas as well, and where the temperatures are around maybe 28, 29, 30, or with the marine heat waves 32 and all. But in the Red Sea, you are seeing corals surviving in higher temperatures. So is there a scope, do you see a scope of, maybe through biogenetics or, having the similar kind of corals or, I don't know, similar species, but with more tolerance levels, so that we can have I don't know, I'm not sure replacing the corals there, but some kind of adaptation measures. You got what I'm talking about? Yeah.
Yeah. I'm not the biologist who works on that. That's not my specialty, but I mean I do see the work going on there, and the answer is, I mean, people are looking at this. We've got faculty and research teams who are looking at the genetics of the organisms, looking for ways that we can genetically engineer these organisms to perhaps expand their range of survivability.
What is the tolerance level in the Red Sea? Do you have an idea? Up to what temperatures does it go over those areas?
The highest temperatures will get up to 34, 35. I think in the Gulf, there are some areas they get higher. That area down, sort of that, on the eastern side of, I think, Qatar, I think it's a low circulation area. I think it gets more.
We have observed even at up to 39 degrees C corals.
Okay, yeah. So and then, another one of our faculty is working on probiotics. It turns out that if you use probiotics, you hit the coral after they bleached with a bacterial mixture that actually can help them recover better, and there's a higher probability of recovery. It works. So, I mean, there are things that people are trying to do and as you say, the Red Sea corals are, they're already living in an environment which is warmer than saltier than most of the corals in the world. So can those corals be transplanted to the other regions? I don't know. This is a problem. What are the other conditions that are present in an area? And I guess the question, going back to Richard's question on sustainability is, and I don't know if I have the answer, but what do we want to sustain? Is it simply human viability? Is it the environment as we've known it? How do we define what sustainability is? And I don't know if I have the answer to that, but I think it brings that to what is it that we define sustainability to be.
Was it?
Assalamu alaikum. I will ask just a simple questions. How to link the biodiversity in the ocean, different ecosystem, coral reef, mangrove, seagrasses, benthic fauna, how to link this biodiversity with the smart technology, the variables which I'm going to measure with the smart technology.
I don't have the answer like on top of my head right now, but I would say we need to run a model on this in order to get to the answer. But I would say to link that to smart technology, I do have too many solutions in my head, but I cannot really give it out right now as I'm not really sure they are the right solution. I need to do some sort of testing and assessment and study in order to answer your question. So far, I think the Center of Vegetation in CBC works on something like this, and I believe we will have a meeting with them to address all the technologies used for testing the vegetations and linking them to a system or something. So my response to your question is that we don't have an answer now, but hopefully in a few months we will get to that. Yeah.
Thank you. If I may follow up on Richard's question, we have been looking into planetary boundaries. We don't have the answers for all. However, we know enough to be alarmed. And in particular, if I look at water resources and the shortages and the inequity in terms of distribution and where climate change fit into that picture, at least for the global water resources, there are reasons to be alarmed. If you look at the air quality issues, there are reasons to be alarmed. So I think if you partition your question into specific elements of sustainability and how to sustain people on Earth, we have enough data that makes us feel alarmed that we need to do some changes to the business as usual model. There may not be enough sensing to look at maybe zooming in some of the biological and diversity issues, but I think at the global scale, with the basic human need for water, for food, for air quality, I think we do have enough knowledge about the global stock of these resources. Now, we thought we knew before the peak oil concept came, we thought we knew that when it comes to energy, but because of the technology, we have exceeded the peak oil concept. But it's only because technology allowed us to have more efficient and access to some of this oil, which was not available earlier. Anyway, but it's a relevant question to ask, and we should be always keeping it in mind. There are planetary boundaries, and there are biological capacity that any environment can, and we have been exceeding that in many dimensions.
Thank you very much, Doctor. I think I'm afraid we will not be able to entertain any more questions. Sorry, we have to wind up. Okay, the last question, please. Yes.
Assalamu alaikum, Khalid Sheikh, National Center for the Wildlife. I'm really interested about the coral reef, and there's a question coming, why the coral resilience in Saudi seas, there is a high adaptation. I would like just to share some information. The optimal water temperature for the coral reef is between 23 to 29 Celsius. I would like just to share some studies here by Dr. Mohammed Qurban, the CEO of National Center for the Wildlife. Dr. Muhammad did his study in Arabian Gulf in Jannah Islands, and let's imagine is the measurement that water temperature at 9-meter depth. It was 39 Celsius, which is almost 10 degree more than the optimal temperature. The secret things why the coral we have high coral resilience and the coral adaptation of the impact by temperature, because we have genetic characteristics which is different than any coral in the world. So there's high adaptation of our corals because the genetic and kind of corals in Saudi Arabia. Thank you.
Okay, I would like to say these are exceptions, like outliers cannot be generalized. So there may be some corals, but we cannot say that this is applicable for all the corals, because in corals there are different families. So maybe some corals are more stress tolerant, so that we cannot generalize the entire thing. So there are some corals that are very sensitive, they're dying. So not all corals are living at 39 degrees Celsius. Okay, I would like, oops. Okay, the last question, please, yes.
Last question, because we're working in eDNA-based study. In our starting stage, we faced a lot of difficulties to getting the reference data, genomic data. Because in future, to conserve and monitoring, we have to enrich our database to sequence atlas, gene atlas like all flora and fauna in Saudi. Because nowadays the sequencing technology is very cheapest, so massive whole genome sequencing like anything we are planning to in future.
I think we didn't get the question. Can you please repeat?
We are now in Saudi have in genomic program, like a lot of in medical field, but in our environment related field, our genomic database is very poor. So we have to make a policy about to all genome, our species, like we have to generate gene atlas for in future for monitoring our temperature related climate changes. So we have any initiative to take this, make a whole genome sequencing to enrich our database related to Saudi or Gulf scenario.
I think that's what organization are you with?
He's from KFUPM.
Oh, sorry. Okay. Well, I think if I remember correctly, I think NCVC is working on a national genome project to create an atlas for the kingdom, and there's been discussion of extending that from the terrestrial environment to the marine environment. And, so I think that's an excellent, it's an excellent thing that's needed, so we know what's there, and, we have the tools to do it. It's just, takes some effort and money, so.
Okay, I would like to call upon Dr. Luwai Hems to announce the best poster, as well as provide the concluding remarks.
بسم الله الرحمن الرحيم والصلاة والسلام على سيد المرسلين سيدنا محمد وعلى الصحبة أجمعين. For track number 4, Smart Technologies in Environmental Monitoring, and the title of the poster, proposed intelligent irrigation system for Riyadh City using fuzzy logic. Sarah Sadoun, King Saud University. Please welcome Sarah. And I would like really to thank our presenters and for track number 4. I think we honored everybody in the gala dinner except our 2 colleagues here. And I would like to really to conclude the conference by few words, if you allow me. Indeed, it is a pleasure that having you all attending for these 2 days and attending our exhibition. Also the participation from other places and entities. I would like also to thank universities, especially coming from far away like Tabuk, Hafr al-Batin, Hud al-Shamaliyya, Jizan, Al-Baha, King Saud, Al-Amira Noura, especially they were participating by students. So this is really a great pleasure for us. And also for our international guest speakers, for our local speakers, for all our what you call governmental entities and companies attended and presented really in this 3, 4 sessions in the last 2 days. We know that we have some shortage in some of our activities, and I wish really to receive some comments from your side. The website, I think we're gonna activate it again. And the email, which is ending giks.com, you can send us what you would like to say about the activities. Bear in mind, it is the first time for us to conduct such a meeting. And I think if you read the title, نحو بيئة خضراء لبناء مستقبل مستدام, and in English, it is written towards green initiative or towards greener environment and building a sustainable future and innovation. It is a big statement. It is a commitment. Hopeful that we can really deliver in the next time something new for you and add to the legacy of KFUPM and for the kingdom, indeed for what is now going on in terms of the initiatives, the mega projects. And I think you observed with me, mashallah, the percentage of female participation. I think almost 65 to 70% of the conference. We are proud to see all. Also, this is encouraging the male to be more active and enjoy your time. Thank you very much. And finally, also, I would like to say the administration of KFUPM decided to extend the exhibition for tomorrow, up to tomorrow, for families, people from outside to come and see. So usually it is opened by 9 a.m. and we're gonna stay up to 7 p.m. Up tomorrow. Thank you very much. Have a nice day, and looking to seeing you again in King Fahd University. Assalamu alaikum wa rahmatullahi wa barakatuh.